Hello there. Here we are for Boost Week 9 for 2023. Lots of stuff to do today. Lots of discoveries this week. So I'm just going to jump right into it. Let me just go over what we're going to do. We're going to install Linux from Ubuntu server onto a VMware virtual machine today from beginning to end. And so that you have a bare bones Linux. You're probably wondering, well, why that after going through all this stuff with containers? And we're going to get into that. But the short answer is that WSL2 blew up. And it blew up Podman, and it actually stopped me from being able to use those containers that it was using. And if you want to know why I hate WSL2 or WSL in general, I do have a video on that. You can watch it, or you can watch any number of my like 7 to 10 hour co-working videos where I'm screaming and yelling and swearing and spitting at the camera about how much I hate WSL. I cannot strongly advise you enough to avoid WSL. Okay. And that's actually a good segue, because WSL, what is it? WSL is Windows Subsystem for Linux. Technically, it is a virtual machine platform for Windows only that leverages Hyper-V, which is the internal stuff that inside of Windows for doing things like virtual machines. You don't care about that. It's just going to get recommended to you a lot. And hey, dog. And I'm just going to tell you right now, anybody who tells you to use WSL as a beginner, tell them to shut up and to use and then you're gonna use an actual virtual machine that works. WSL2 has blown up so many times on me in the last 2 years at critical points that and it's not just me. Every time I tell this story, I get people come out of the woodwork. Oh my God, I'm glad you told me this because it did it for me, and I thought I was all screwed up. And then I have other people taking bets to see how long it's going to take before something serious breaks with WSL. Seriously, they took breaks. I was like pushing it pretty hard last year, and they was like, okay, and they're like eating popcorn, saying, let's see how long it takes before everything goes to shit. Sorry, there's my swear word for today. So I'm really mad, and I don't want to talk about it anymore. I have done a full review of it. I seriously, there's at least 2 hours of video of me yelling about WSL over this last week. And I break down point by point why I hate it in my YouTube video. I do have a YouTube video about why you shouldn't use WSL. And you're like, well, what should we use instead? So that's going to get us into the topic for today. So again, by the end of the day today, I don't know if we're going to get to it all or not, but by the end of the day today, we have to have one thing done. The one thing that has to be done is you need to have Linux server running in a virtual machine. That's it. And secondarily, hopefully, you need to be able to SSH from Git Bash, which you've already done, and into that virtual machine, just like you would if you had a separate server computer. Which reminds me, there's a couple of other administrative things I want to go over. So last week we learned Vim. I know a lot of you were expecting us to do VimRC today. We're not. We're going to do this instead. I debated about whether I should just finish out this entire boost using Podman. We are still going to use Podman, by the way, and you still need to understand containers. So the thing to take away from this is virtual machines and containers are both very important things to learn, and we will learn both of those things at a beginner level in the beginner boost. And so you already know how to use Podman as a user. You're not going to be making containers. You're not going to be making your own virtual machines. You're going to be using containers and using virtual machines. These are skills that apply to everyone, including the most focused machine learning engineer who doesn't want to learn anything about Linux. They just want to do their machine learning, to, the full-blown hackers and sysadmins who want to, get down and dirty with everything inside of the Linux kernel eventually. All of those people need to know what a virtual machine is, how to use one, what a container is, and how to use one. So let's just take a moment about content. So that content for me is going to go into the beginner boost. Okay, so we spent quite a bit of time discussing this as a group in the whole stream this week about where to put which content and how to organize it. This is something that I stress about much more than I probably should, but I really do, because I really want the easiest possible path for beginners to take that's not confusing. And I know I'm on the right path, because I had somebody tell me this week, actually, that for the first time in their life, they're not afraid to use Vim because of the way we approached learning Vim last week, which is hands down the best way to learn it in a very incremental way, so that you're not overwhelming people. And it's very easy to get overwhelmed with Linux, and the terminal, which is why it's so important that we get the order right and that things don't blow up on you like WSL. So my worst fear right now is that we are exposed, because we have people who have been following the boost. It's still my main overview video about how to quick start and use podman containers. We have people that potentially could wake up one day, turn their computer on, and not have any of their boost container work for them at all. And I have never had that happen with the virtual machine option that we're going to use now, which is, by the way, what we did last year. So I don't want to get into why we changed. I thought maybe we could do it faster with podman and desktop, and I was wrong. So anyway, here we go. The first step is going to be the beginner boost. We're going to do, so the new standard for beginner boost is going to be, the thing that you're going to use if you choose to follow this is you're going to use Linux Server, Ubuntu Linux Server, running in VMWare Player, and you're going to attach to it via SSH. And a little thing about SSH is a way to remotely connect to another computer. And some of the people in this community may remember that I was struggling with the whole podman thing, trying to figure out how we were going to teach you secure shell. Well, that problem's gone now, because we're back to being able, to SSH into a computer, even though that computer is running inside your computer. I know, mind blown, right? That's what a virtual machine is. And so the next step after that, and by the way, I can take no credit for this name. I did not have a name for this. I had a HomeLab init name, but I did not have a name for this. And I was like, okay, the next step should be running Linux on bare metal. And we had a bunch of recommendations, and Full Metal Linux 1. In fact, I love this name so much. I want to make this learning, this learning segment series, whatever you want. I want to make this learning series just because of the name. It's like Full Metal Linux. That has got to exist somewhere. I mean, it's probably already out there somewhere. Go do a search. I don't know. There's no trademarking or anything. But my God, that is like the coolest name ever. So by the way, we moved in Introduction to C coding. We moved it to Full Metal Linux. So now Beginner Boost is just going to have an Introduction to Go coding. And Bash is going to have full Bash coding, Introduction to Python, Introduction to Go. Not enough for you to get a job or learn Go or Python, but just enough for you to get a feel for it. And Full Metal Linux is going to have an Introduction to C, and it's going to have an Introduction to Assembly, so you can read it. And it's going to include installing and I'm just going to go with my most famous, most mature, the never done me wrong desktop distro. No, we are not fighting about desktop distros. You can fight about that on your own time. Linux Mint Cinnamon, which is based on Debian, which is which is Ubuntu really. It's Ubuntu, which is based on Debian, which is blah blah blah. And we're actually going to go through an actual cheap laptop install, and I'll use a capture card and show you how to install Linux Mint Cinnamon and breathe new life into old hardware, which is one of the greatest joys of Linux. Whether or not you are that focused machine learning person, or you are somebody else, you may really, really love taking that old machine that your grandma or your aunt still has because they didn't want to get rid of it because it still had their old taxes on it, and they didn't trust anybody to delete everything off of it. And so now it's sitting in a closet somewhere and it's being unused, and now you can just put Linux on there and go to town. I mean, it's really fun. This is a real joyous experience, is installing it, but it doesn't belong in the Beginner Boost. That's just to help you learn the terminal and get going. And then the last thing is going to be a series on getting your home lab going, setting up networking, setting up DNS, Kubernetes, VPN, routing, all that jazz. And what kind of server to buy to do all of that, how to get a discounted server, whether you should buy a refurbished server, how many cores do you need, do I really need my own firewall, how do I configure a firewall? That's all home lab init. And as we get good every year doing these series, because I do want to fit all of these into 2 hours a Saturday, we will be doing that. Now, the beginner boost right now is still estimated to be about 30 weeks. It may come down in time with something else I wanted to tell you about. I'm now starting to make, I've always hated VimTutor. We did VimTutor last week. It's always bothered me. And so I just started this week. I started to create a series of tutor-like binaries that you can run that will give you, so let me show you what's up here. This is just coming. It's not ready yet, but you'll be able to run like Learn Vim, and you'll get, it's my own version of tutorials that actually use Go to do Go templating so that they can detect the system that you're on. So like, for example, here it says, I noticed you're learning Vim on Linux, whereas I can run the same thing on Windows and, and on a Windows machine, this is Windows with Git Bash, and on the Windows it says, I noticed you're using Windows. And so what it does is it gives you things like the magical, the magic wand commands. You remember these from last week, exclamation point, to use the filter command. And then we can send that to Bash, and you can replace that with its output. So in order to practice using filters, which is the most magical, powerful reason to use Vim, you can now do that in the tutorial that I've created. And I've already got the first part of the tutorial. If you want to give these tutorials a follow on GitHub, I'd appreciate it to improve their visibility. The GitHub / I'll put a link, but GitHub RWX Rob Learn Vim. And so here it is. Come on over and give us a star if you want. As I said, it's not ready to use yet. If you have Go, you can install it like this. If you want to install Go from the command line, by the way, we wrote a script to install the latest Go from the command line without a requirement for APT or anything. Actually, this will work on all versions of Linux and that have Bash. Anything, actually, it'll work on Mac too. That anything that has Bash, and you can run that to install Go if you want to. So that's just kind of a preview of what's to come. This goes along with this because everything that I cover in these videos is eventually going to have a binary that goes with it. And that binary is going to create a file, and then it's going to ask you to do things on the terminal, from the terminal. And then as you finish that, you can go in and change and update that file, and then the file it'll be kind of like a grader. It'll like check your file out and see if you put the right thing or if you really did it, and it'll look at your system and see if you did it. I actually created something called Skillbots 8 years ago that did this very thing independently. It would run as a separate process, and it would watch your history and see if you did everything right. And I'm probably going to make that again as well. So this is where we're going to do that. As to when these other things are going to take place, they're not going to happen until the beginner boost is over, which means they're not even going to be, ideas in anybody's head until probably January. So traditionally, January through May is when I regroup and I write new content, or I revise the content for the beginner boost. We'll see. We'll see where we go for that. We also traditionally learn C over Christmas, so I think one of the things we might be able to do is depending on how December goes, we might be able to do Full Metal Linux over December and over the December holiday, which I don't know if everybody has that much time off, but we'll see how it goes. So I know everybody wants them. Every time I talk about these things, they want them right now. They want them yesterday, and I can't answer that other than to say, let's get going so we can get to that point. I'm actually in this other window here. You can see this is the shell that ran. We also did, it's pretty cool too. It actually detects if you have Python on your system. And if you have Python on your system, you can do bang, bang, Python 3, and it'll actually do that. So that whole idea of like editing, bang, bang, BC, and you can do that. So same idea of a tutorial where you're changing things as you go, but it's what I really love about this is that the underlying architecture and design of this kind of learning is the same sort of thing that you would be doing if you had a linter while you were coding. So something that's helping you code properly and keeping your syntax correct and stuff, right? So the hooks to do this kind of stuff already exist, and a lot of it is already in Vim. So all you really need to do is write something that checks to see if what you're doing is correct, and then update it, right? And that's what we're going to do, and it's all going to be based on Vim. So that'll be a big requirement for you to learn Vim initially to do all of this stuff, or to edit the file. All right, so that's it for that. Let's go back to what we were doing, the main event. So let's talk about the difference between virtual machines and containers. Okay, so I'm only going to spend a few seconds on this, minutes. We've already talked about it before this year, but I'm going to revisit it again. So, in fact, you can do a search on. I know for a fact that there's a really good graphic on the internet for this. So let's do a search, just like you would. I like to recreate what you would be doing, right? So, what is the difference between? Now I would do this from the command line usually. Between virtual machines, machines and containers, and you're going to get a bunch of hits. There is one that has a diagram. Yep, this is the one. This is one of them. This is Atlassian, pretty reliable company. They made Bitbucket and a bunch of other things, but they're not around as much as they used to be. But this is actually a really good explanation of the difference between them. Both of them, in many ways, accomplish the same goal. They get you the containers are not primarily to get you a Linux distribution or to get you a machine. That's why the word machine isn't in the name. It can be a bit confusing because containers are often used, as we have been doing, to act like a machine. I mean, you guys have seen us doing this, right? Podman run remove Alpine. So we're going to run Alpine Linux, right? Well, I have an Alpine Linux distro now that I'm running and I'm logged into, right? If I wanted to do Ubuntu, I can do Ubuntu. So, I'm running a server. We did this with Kali. What was Kali's? You guys remember Kali's? I don't remember it. Is it Kali? I think it's Kali Linux rolling distro. Kali rolling. I can't remember the name of it. If anybody remembers, the point is, it's got a more interesting command line. That's why I wanted to go pull it down, but I don't remember it. I don't remember it. Anyway, the point is that there are many containers that, even though a container is not a machine at all, the biggest difference between a virtual machine and a container is containers share the same machine, and virtual machines don't. Okay. Virtual machines virtualize separate machines, whereas all containers share the same machine. I think that's probably the biggest definition. The containers are made to be, so Mr. Rob, what's the difference between that and just having a separate account on the system? Well, if you have two separate user accounts on the system, I can go in there and go look at the other person's account, right? So actually, let me show you. So if I want to go, let's run Ubuntu, right? So I can, there's no user here. We could do add user. I don't know if this is going to even be on there. Okay, so add user. Just to give you an idea. RMX Rob and password. Answer all these. Okay, boom. So now I can ask you to RMX Rob, and now I have another user, right? And I can actually add another user. Add user. Foo. How about just say other? How about that? Password, and answer all this. And now, as you can see in /home, we have two users. All right, we have two different users there, right? But the users can see each other's stuff. So if I do, to a degree. So sudo / and they definitely would be impacted. All the resources on the machine, the amount of memory, the amount of disk, all of those things are split across the users. So if one user takes up all the processing power because they want to do something stupid, which believe me, they do, because in the 90s we didn't have containers, and I tell you what, when we were managing multi-user systems, people were stomping on each other's processes all the time. My processes are being starved. I can't do anything because so-and-so is running their stupid process. And in the age of machine learning, I support machine learning people. I cannot possibly imagine what it would be like to try to have 5, 6, 7, 800 machine learning specialists running their own data jobs to do their own data analysis and crunching on the same machines with no separation between them at all. They would be totally stomping on each other all the time. So that's why the Linux community invented containers. Okay, and that's very important that we give credit where credit is due. Linux containers, which at one point we call them shrewded things. Linux containers were invented by Linux. Containers were invented by Linux. Now BSD has them now and all that. But what they do is they isolate all of the stuff that could occupy resources, primarily memory and CPU, and permissions and security and stuff like that. And they keep those containers separated from each other, even though they're using the same underlying resources. And to a degree, they're still kind of competing for resources, and I don't want to get into that. That's part of what container management does. The really great thing about containers is that you can just spin them up really fast, right? And that's why we went to Podman instead of virtual machine. You're going to see how much longer it takes to set up a virtual machine today versus just running Podman to run like we did, right? You install Podman desktop and you get, I got Ubuntu in 30 seconds? I got and now I just have to add my customizations to it. So containers are lighter, and they're, strictly speaking, they are encapsulated applications. It just so happens that Alpine and Ubuntu and all these, when we do those Docker run or Podman run, we're actually running the login for a simulated system. So the application itself is the shell to a very small minimized version of Ubuntu. And I want to focus on that word minimized. So when I run a container, when I run a container for Ubuntu and I'm like, oh, hey, man, LS, there is no LS. Because it's a container, as I said, it's not a real Linux distro. It's a distro that's been minimized to reduce all of the crap so that it's really small. In fact, most of these containers are under 1 gigabyte, a long way under 1 gigabyte. Imagine that. Imagine installing your entire operating system in under 1 gigabyte. I mean, even the big SKILSTAK image that we made, it didn't ever go above 2 gigabytes. For an entire, machine or distro. So workspace containers, like the ones we've been using up to now, they're still valid. But the important thing to remember here is that containers are designed to be really small. And there's another thing that's super important. And forgetting this is going to get you in trouble. And I kind of forgot it when we were doing this just now. When you use a container, the idea of a container is you're supposed to be able to throw it away anytime. It's called ephemeral, right? So I'm going to put this word here so you can remember it. So containers are ephemeral. And I have been kind of cheating for the sake of what I hoped would be ease, ease of learning. Did I spell it right? Ephemeral. Ephemeral means that they can be thrown away and discarded at any time. So that means when you run, you start up a container, you do it all its thing, and then when you stop the container, it deletes itself, goes away, and does something else, right? And this ephemeral nature of containers is what allows us to make containers the center of the universe when it comes to managing architectures that are complicated and microservices. That's what Kubernetes is all about, right? So just in case you're wondering, the idea of a pod is more or less a container that operates. It's strictly speaking, it's one or more containers that are grouped together into a pod. And then they get managed by Kubernetes, and Kubernetes is this big sort of kind of enterprise architecture operating system, sort of. And then those things get treated; those pods get spun up, and maybe 4 pods will happen, and they'll all try to do work together. And that's so understanding containers is absolutely critical to doing anything today. You have to know how to use them. And if you're going to do anything in the enterprise architecture space for operations or development, you have to know how to make containers. We are not going to cover making containers in the Boost. I told you that, but we will cover making containers in Home Lab and Knit. We're not even going to call them. Full Metal Linux is the polar opposite of containers, right? Full Metal Linux is like how to get Linux on devices, on laptops, on Raspberry Pis, on Jetson Nanos, and all of these other great stuff. And so Linux on Metal is a thing, and virtualization, running in a virtual machine or running a container, is the polar opposite of that, right? This is the virtualization of one or more of those things that define what it means to be a Linux distro or a Linux thing, and puts it on a layer above that. Now, that layer of abstraction, as I said, that has given us a lot of flexibility. We can spin up a container here and there and throw it away. But as you know, as you just saw, if WSL goes south and ends up screwing me up and all my containers are dead, right? They shouldn't have been dead, by the way. It's something to do with the networking for the containers. I don't know what. But anyway, sucks to be you if you actually tried to save something in those containers. So the idea of using a container is if you're going to do any work in a container, you better damn well save that work somewhere. Whether you're doing it interactively and you need to save it to Git, or you need to commit something to a database, or you need to mount a volume and write it to a disk drive that's not it's outside, that's shared with the actual host system on the Metal. All of these different ways to persist data, save data, that's very essential in the container world, because the idea of a container is more or less a running program. I'm going to run this complicated program or whatever. I'm going to do some things. I'm going to save some things. I'm going to calculate some things. Maybe I'm going to serve up a web page or two, a REST API, and then I'm going to die. And somebody else can replace me at any time, and that can go pick up and do different work. So that's very, I know I spent a long time on this, but it's super important that you understand that that's the difference between containers and a virtual machine. A virtual machine is exactly what it sounds like. A virtual machine in every way is the same as an actual metal machine. And the term metal has bare metal or metal has come to mean operating systems that are running non-virtually. And the thing that's kind of funny is it's virtual machines have become so dominant in how we do everything that people, when they say machine today, they are almost assuming it's a virtual machine. You almost have to say, oh, it's on metal. And people have actually replaced the word machine with metal in architectural design conversations, stuff like that, because they know that the term machine, the shortened version of virtual machine, is referring to a virtual machine, which is kind of weird. So virtual has become the definition of what a machine is for most people. And so you actually have to tell them that, no, it's on bare metal. Oh, okay. Okay, so being on bare metal, as in Full Metal Linux, isn't that a great name? I love that name. Full Metal Linux. Full Metal Linux means running on hardware, like directly on hardware. And there are lots of reasons to do that still today, particularly on the edge, they call it, which is like tiny devices and things like that. We're going to talk about all of that in Full Metal Linux. So I'm super excited, if you can't tell. I can't wait to get to that part. Mostly because I've been so distraught by the reality of not being able to cover everything in the beginner boost, even after 30 weeks. So anyway, let's get started installing a virtual machine. Let's talk about the layers really quickly. As you can see here, virtual machines have an operating system. And all that stuff I was telling you about containers, it says, but Mr. Rob, you just did Alpine versus Ubuntu versus Kali Linux. Why doesn't it say guest OS? There's no operating system here. Why? Because technically speaking, it's still using the operating system that's hosting it. There's no actual operating system. It feels like an operating system when you run, Podman run Alpine, right? It feels like you're running an Alpine operating system because the application is it's got its entire, it looks like an actual guest OS, but it's not. And this is why you get into trouble, right? Because there's nothing there. It uses a container engine. In this case, we use Podman container engine. I've already told you, don't use Docker. Don't even think about Docker. Don't go to the Docker site. Don't use the Docker name. Just banish Docker from your vernacular, and you'll be better off. Docker has done several really horrible things, business-wise and technically, to people. They may have championed the use of LXC, which was already invented by the Linux community for containers. That's great, but Docker is a disaster of a company. Don't host your stuff on Docker Hub. Don't use them at all. You've been warned. I know Red Hat's got their problems, but nothing. If you're going to use containers, use Podman. Boom. Use Podman for containers and host on GitHub if you want to. If you have problems with Red Hat or Microsoft, fine, but I promise you they will be infinitesimally smaller than problems you will have with the dependency on the Docker organization. So I'm just putting that out there. If you don't agree with me, fine, but you've been warned. So if you don't want to know why, search for why does Docker suck, and you'll find out. So the container engine is Podman in this case. There are many container engines, and we're not going to get into that. You don't actually need to get into that until you're planning your own home lab init, the kind of thing. As a user, though, you do need to pick one, right? You need to decide, am I going to be running Docker commands all day? Am I going to be running Podman commands all day? Pretty much. There are other container systems tools out there, but those are the two primary ones right now. Host operating system. So you'll see that they have the underlying host operating system and they all use the same one. In my case, that is, I was going to say, you can't have containers on anything but Linux. In fact, it kind of makes me angry that they don't call it out here. The one thing that they're missing in this diagram is that this layer here that says host operating system, and the container engine right here, they're not telling you the truth, okay? The truth is you cannot have a container on anything but Linux. But I'm running it on Windows and Mac. No, you're not. You're running it on a Linux virtual machine. So your host operating system is not Windows. In this case, there's actually several layers here. And this is why it blew up, right? Because the host, the container engine, in my case, is running on a behind the scenes emulated version of Linux that's being run with QEMU, which we're not going to talk about here now. And that is being run inside of a virtualization platform called WSL2, Windows Subsystem for Linux, which is running inside of a Windows host operating system. Not technically, it's kind of next to it. So you see what I'm saying? There's like so many layers there that what we're going to do is we're going to get rid of all those layers. And we're going to run a guest OS directly on a hypervisor, which is directly on the machine. So there's only like 3 layers when we go with a virtual machine, a lot less to go wrong. And that's why virtual machines are far, far more stable than any container engine on Windows or Mac would ever be. Because, and by the way, that's also the reason that my container engine that I'm running on my Linux machine is fantastic. Because why? I took out 4 layers. Because I said you have to have Linux to run containers, right? Well, if you're already running Linux on your server, which I'm running my bare metal server back here. If you're already running Linux on your bare metal server, guess what? All you have to do is run a container engine on that. You got 3 layers, period. You have the application, you have the container engine, and you have Linux. That's it. You don't have all of the other emulated pieces to go wrong. There's nothing to break. You just have the true thing. So today, and I'm done talking now, I promise. I mean about this, but it's so important that you grasp these differences. It really is, because what we're going to do now is, I know I still wanted to shoot for Windows or Mac, right? So what we're going to do is we're going to install a guest operating, a guest operating system. We're going to install Ubuntu Server, the same exact software, line for line, the exact same software, the exact same thing that you would do to install on bare metal, we are going to do into a virtual machine today. And that way, when this thing is running, it doesn't matter if it's running inside of Windows, because why? Because it is a virtual machine in every way, the bit for bit, that operating system, that is the actual operating system. And the emulation of that machine happens so low, at the lowest level, the hypervisor level, that all of the applications and everything running inside of the virtual machine have no idea that they are actually running on a virtual machine versus a real machine. They don't know. They don't know any difference. So there's less problems because there's nothing to go wrong. There's no minimized version of it like that we went through. It's all the actual stuff. So if you want, this is also really good if you want to like test, filling up a disk drive or something like that. Obviously, try to fill up a disk drive on this guy, you're going to blow away your host operating system because there's no separation. But there is definitely that separation of virtual machine. Virtual machines are also the basis of the entire cloud ecosystem. All right, so when you spin up a virtual machine inside of Azure or Amazon or GCP or Google or any of them, if OpenStack, all of them are using a virtual machine platform. Specifically, they're using the most important virtualization engine on the planet, KVM. And KVM was developed by the Linux people. And is maintained by Linux and is still the most powerful of all. And KVM is really the only virtualization engine that in HomeLab init that I ever want to use. There's other ones, but unfortunately we can't run KVM on Windows, so we have to grab a piece of software that provides the hypervisor. And this gets a little complicated because Windows has its own hypervisor, right? So I'm just going to cut to the chase. We're going to do what 90% of everybody would do who needs to run Linux on Windows. We're going to install the most stable, the most well-known, and frankly, some of the most proprietary virtualization software you can install, and that is VMware. So, and why are we doing VMware? Because if you were to use QEMU, then you'd have to do all of this instead. Raise your hand if you want to learn QEMU as a beginner and learn everything about the command line. It's the chicken and the egg situation, right? You don't really know the terminal yet. Look, if I have to say this because a few of you, I love QEMU, right? I love it. I love QEMU. I love KVM. QEMU is an emulator that will do either emulation or virtualization. It's worth mentioning because it does not fall into this graph here. QEMU is a piece of magic. QEMU is another Linux, ish kind of thing, Unix-ish thing. QEMU, the Q stands for QEMU emulator. This is large. This is not a beginner technology, unfortunately. We tried very hard this week to make it into a beginner technology. It's still not. You still need to know how to do the terminal. And so in the beginner boost, we are going to stick with VMware Player, which is a single download. In fact, why don't you go download that right now while I'm talking, okay? Pause the video or whatever and go download VMware Player. It's free. VMware free player. Download VMware Workstation Player, okay? Download VMware Workstation Player for free. I got version 17. Just so you know, I have actually got a professional license. It's very little money for me compared to how valuable it is. I have been a very happy VMware Workstation user since, 2001, 2. I've been using it. It's the most professional. It's the most accepted virtualization software. In fact, my corporate issue MacBook Pro comes with VMware so that I can run Windows applications on it. VMware, I used to run VMware on Linux when I first started SKILSTAK in order to allow students to run GameMaker to build games, which is Windows only technology. So whether you are running it to run Windows on Linux host, or you're doing it to run Linux on Windows, that's what virtualization buys you. VMware is also most notably the best at leveraging your internal hardware and the infrastructure there. So I could pass. I mean, I know there's other virtualization technology out there. Every time I talk about this, somebody's gonna hit me with Vulkan and all the other cool things that exist for virtualization on Linux. But this is by far the most mature, the longest standing, and the most adopted by enterprise and education. So download Workstation Player while we're talking about it, and we're going to go through and we're going to install. That's going to be the last hour for today. It's going to take us only about 30 minutes to do it. So go ahead and download that. The other thing you need to download is the Ubuntu Windows image. And so go ahead and get started downloading that, and we'll talk about it a little more as we go. So for that, you can just go search for Ubuntu Server, and you can find download Ubuntu Server. And I'm going to actually run through and install. We tested it this week to see how long it would take to do this. We actually tested creating an image for you and decided against it, frankly, because there's almost nothing you have to install, because it just works. So here we go. Manual server installation. So click on download Ubuntu Server 22.04 LTS. That stands for long-term support. This is all free. The player is free. And the only limitation with the player that you need to know, we'll get into, is that it can only run one VMware workstation at a time. I mean, virtual machine at a time. But for the beginner boost, we don't care. If you decide you really like it and you want to do it so that you can do any of the things we talked about, and you want to have you have enough resources to run a bunch of them, you can consider paying whatever it is. I think it's like $200. I don't even know. But you have to re-up every year, and so I had to pay my $100 to get to Windows 6 to Workstation 17. As proprietary software goes, I have no problem saying that VMware Workstation is worth the money. This thing has saved me so many times, and it really does pay off. There is a question in the list of questions: why VMware? I think I just covered that, right? And I don't want to go too negative, but I am definitely going to tell you why not to do QEMU. We already did that. The reason not to do QEMU is because it's too complex for a beginner to use. QEMU is really great. It's an emulator, by the way, which means you can actually run BSD Unix on hardware that would otherwise... Virtual machines normally have to be, the same chipsets, right? You can actually run, check it, you can actually run ARM... you can emulate entirely different chipsets with QEMU. That means you can not only simulate, a machine that's running on the same underlying hardware, AMD 64 or whatever, right? Virtual machines are, strictly speaking, they're limited to usually to the same architectural hardware underneath the whole thing, which means, if you're on a Mac, you know what I'm talking about, right? Mac Silicon or whatever the hell. So, Mac Silicon is actually ARM, right? Well, how could I run software that's designed for ARM on a machine that's got Intel AMD 64 on it, or AMD, not Intel, AMD 64? Well, you can't. The only way to do that would be through emulation, and that's where QEMU comes in. It's extremely slow because it's all software emulated, right? It's extremely slow, but it's the only way that you can run code that was written for an entirely different chipset on another machine. And so QEMU is the darling of the device industry and people that want to do development and people that deal with full metal kind of things, because they can use QEMU and they can write code that's going to run on some weird device or in a stop sign, or I mean, they can do all kinds of magical things with Kimu. But it's designed. The problem with it is that it's never. It's the bar is still very high. It's that this. I mean, this we have pros that use this all the time, and this is the best that they came up with. Right. This was the simplest thing that they could come up with to run it on Windows. And believe me, they know what they're doing. And we were actually going to put that into a script and have you download it and run it and all of that stuff. And we decided against that for one reason. It's just so easy to download and double click, because that's all you need to do with VMware Player. All right. That's why we're using it. The question always comes up, why aren't you using VirtualBox? I'm just going to spit it out. VirtualBox is absolute trash. And if you have used VirtualBox and you like it, fine. It's been taken over by Oracle. The team that's running it has no idea what they're doing. In fact, the reason that I started using Podman Desktop was because, or I started using VMware again, was because I was using VirtualBox and I clicked on the button to upgrade. It said, there's a latest release. Would you like to do it? And I said, sure. I wanted to be a good, person using the thing, always upgrade. So I clicked on the upgrade, and all of a sudden I couldn't run my virtual machine anymore, and it was totally hosed. And I was like, really? And then I went through, and there was this big, long issues list. And at the end of the issues list, it says, oh, well, if you have Windows 10 in this situation, blah, you should never upgrade. I said, that would have been really nice to know before you just fucking destroyed my virtual machine. VirtualBox is a disaster waiting to happen. If you depend on it, you will be disappointed. Its UI sucks. It doesn't do screen resizing properly. It's made by Oracle. Oracle has openly said they're not supporting it going forward, and then they changed their mind for some reason. We've had people who work in Oracle on my stream throwing it under the bus, saying, yeah, we're getting off of it inside here inside of Oracle. We're abandoning it as well. I can't give, that's just somebody who claimed on Twitch to be working internally at Oracle. I know it could be lying or whatever, but it could be a rumor, but nobody wants this thing. It's totally bad. The only reason people like it is because they say it's free. It's not free. It's completely domineered by Oracle. And if you think Oracle is better than VMware, oh my God. So don't use it. Just stay the hell away from it. Yeah. So, VMware doesn't, yeah. Oh, somebody is criticizing VMware for not having custom networking. Yeah, like every beginner is going to want to do that. Every beginner is going to want to use custom networking. What a great idea. Look, here's the thing. People who push for Kimu and VirtualBox don't care about the concerns of beginners. That's been proven over and over and over again, as in just the last comment just now in the Twitch chat. Somebody who does not care about beginners, who's like, I would never use that because I can't customize my own networking. You don't want to customize networking. You're like a machine learning focused person who just wants a version of a command line to use to do your machine learning. Do you care about networking? No, you just want to get it. And by the way, you can do networking. You just have to buy a workstation. And by the way, if you want to be that person eventually, you can do it without using the shitty Oracle VirtualBox. You can actually come around and you can do it right. And we're going to show you how to do that in Home Lab Init, which means that you can actually use Kimu, which is way, way, way better. Kimu, KVM, libvirt, and Virt Manager, which are the projects that are supported by the Linux project itself. And so you skip way over using Oracle's crap. You can go straight to using the good stuff, the stuff that all of the cloud uses, KVM. And you can set up your Home Lab Init using Kimu, libvirt Manager, and all of that great stuff on your own, virtualized machine. So don't think that using Player is gonna hobnob you. It's gonna hobble you and keep you behind because it doesn't do networking. Because you're gonna be doing actual networking using your own virtual machine servers. You can also do network emulation even with the laptop, and we're going to practice doing that. The only thing you care about even with networking right now is what an IP address and what a DNS name is. You don't care about anything else because you're a beginner. You don't need to care, right? You just want your stuff to work. those people who do want to get concerned with networking can use the other stuff later on, and they can skip right over it. So saying that VMware doesn't even allow beginners to do their own networking is stupid. Honestly, it's stupid because it doesn't consider the needs of a beginner. Let's go forward and talk about the next thing here. So you've downloaded VMware Workstation Player. You've got that on. We've talked about this. We've talked about networking. By the way, networking is one of those things that you can do on your own using virtual machines. And we're not going to do it, but this is one of the things with VMware Player wouldn't let you do, and it's fair to say this. As I said, you can only run one virtual machine at a time. That's great for beginners. But if you wanted to run 5 virtual machines and you wanted to practice networking them and modifying and setting up your own internal home network with virtual machines, you can't do that. Nor would you want to do that on your Windows machine. You would want to do that on an actual system that's running KVM. You would want to do that on your own server. So before you get into all that networking and stuff like that, by the way, you can script all that from the command line. You can script it all from the command line to bring up, once you've learned all the scripting stuff from the boost. So that's why we're doing it. All right, so let's go back to actually downloading. Hopefully you got these 2 things downloaded. Once you have those 2 things downloaded, then you just need to install. I mean, I don't have to tell you how to install it, whether it's Mac or Windows. Again, we're only supporting Mac or Windows in the boost. If you have Linux on your desktop, consider yourself ahead, but we're not going to cover that until this step, and that's when we're going to fight about dashboards and desktops and all that stuff. And right now we're just setting up a server on Windows or Mac. Am I suggesting use VMware Player on Linux? Hell no. Okay, but no, don't do that. But this boost is for Windows or Mac people, people who are having their very first experience. All right, let's go. We've got it down. So you have VMware Player installed. Once you have VMware Player installed, you can start it up. My preferred way to start anything on Windows or Mac is to do the search. On Mac, I think it's Command Space, and on Windows, it's the Windows key. I type Windows and I type Player or VMware Player. Actually, it was right there already, but I want you to practice. So VMware Workstation Pro. I have Workstation Pro, which is the full thing. You don't need that. Just run the player. And again, mine is licensed, so there may be things on it, which I went through it and confirmed yesterday that there was some stuff on here that was not. And here is a virtual machine that I already have running. I'm just going to give you a preview of what we're shooting to do. And so we're gonna double click on this, and this is gonna pull up. This is gonna pull up a virtual machine. This is the end goal. Okay, so this is a machine that we have that is running right here, and we can do all our commands that you just learned, and you can do them either from the emulated display, or you can log in from your terminal. So then you can start up a new terminal, a new Git Bash terminal. You've already installed Git Bash. We did that another day. And you can SSH into this machine. Let me see if I can go back. Where are you? All right. So wait, where did you go? There you are. Okay. So then we need to look for the IP number. So IPA, it will actually be on the screen. You won't need to go dig for it, but here it is down at the bottom here. 192.168.1.23. So we are going to talk a little bit about IP, what they are. IP addresses are just addresses of machines on the network, period. That's all they are. And names that go with them. So, and then you have SSH, which is already installed by default with Git Bash. When you install that, you can install to 192.168 what was it, 23? 23, all right. So, whoopsie. I forgot. You have to click off of the window. Yeah, 23. All right, so... and yes, in case you're wondering, I'm going to deliberately fail here. It's trying to connect as Rob. Well, there is no Rob, right? So let's do Control C to get out of that, and let's do the user that we don't know SSH yet. But we're going to learn it. So we're going to do RW. What did I call it? Oh, user at. So we're going to do user at password. And there we go. So there's your beginning user. Now Now you're obviously like, but my prompt is all screwed up. Well, we're going to start to work on that. It's not that hard to do. In fact, that's now that you know VI last week, you now have enough information to start customizing your VI and stuff like that. Okay, even though you have enough information right now to already do kind of the customization you need to do. We debated long and hard about how much to customize here, and I'm really glad that we decided to not do any customization and let you do all the customization, because you will learn while you're doing it. So that's not the case with the workspace container, right? So let's actually, I'm going to go ahead and pause this player. Do you want to suspend your virtual machine? I should probably exit first. All right, so we're going to exit there. Yeah, let me just make sure I have my thing here. Are you sure you want to suspend your virtual machine and exit? Yes. We haven't figured out a way to do snapshots, which you normally have to pay for, and stuff. So, wait, where did my player go? Where did my player go? Oh, here we go. VMware Player. All right. So here we go again. In fact, we can keep that one around. I'm going to rename this one. Let's rename it. Let's say working, or let's say solution or something. I don't know. So we need to make a new one. So we're going to click on home, and we're going to click on create a new virtual machine. And we're going to do, so, okay, you remember that file you downloaded? Did you download the file? Remember we clicked on Ubuntu? I'm going to go back to it and remind you. We went to download Ubuntu server, right? And then in the downloads folder, or if you're Windows or Mac, same thing. It says here, install disk image ISO. So you're going to go browse, and you're going to find your downloads directory, and you're going to find that .iso file. In my case, it's Ubuntu 20, I think of all of our case, Ubuntu 22.04, live server, blah. You want to get the one for your machine, and then click on browse. Actually, if you need to still find it, that's what you would do. And then click on next, and you can name it whatever you want. I'm going to name this one Boost. You can change it later, obviously, 2023. You can name it that if you want to. The thing that's cool about this is that you can, even though you can only have one running at a time, you can still make multiple of them, right? So if you want to make one and run Kali Linux, and you want to download that, or you want to make one and run, Rocky, which is, Red Hat clone, or whatever, you can use it, or you want to install Windows. Another version of Windows running inside of Windows, which you can totally do if you want to hack on. In fact, if you're going to learn hacking, it's required. It's required. The highest level of training that's offered by Offensive Security that does the OSCP, I think it's the OSEE. They actually write malware for Windows in a virtual machine that runs on a Windows virtual machine. And it's required. If you want to do the training, last I checked, they only offer the training at DEF CON. They only give it to like 12 people. You have to be really good to even get in. And if you get in, you have to have a machine that has X number of cores and a lot of power, because you need to be able to run VMware Workstation. And they require VMware Workstation, by the way. They don't allow VirtualBox. They require it. That's the most elite hacker training on the planet, and they require VMware Workstation. So yet another reason to use it. And what they do is they actually will open up a version of Windows inside of the virtual machine, and then they'll write malware for it that will take it down. And then they'll snapshot the virtual machine, and they'll come back and they'll go back and fix it and stuff. So if you're a hacker, you definitely want to learn this, because you can learn how to own systems without having them. Right now, if you're going to do that, obviously you probably want to pay for Workstation, because you can get, as people have said, you can start using the networking and more complex parts of it. You can run 5 different versions of Windows on your laptop at the same time with different Windows screens, and you can go into the different ones, and you can intercept traffic, and you can practice hacking and all that jazz, right? And those are fantastic things for that type of user. But again, if you're a focused machine learning person, for example, you don't care about any of that, and you don't need to know that. But if you do want to do it, you can go ahead and change it, make a new name. All right, so let's go. Next, beginner boost already exists. All right, there must be something already in that one. So let's do, I'm just going to call it boost instead. We'll just call it boost. Next, maximum disguise. These defaults, we've tested it. Go with the defaults. So 20 gig. Okay. By the way, this is not going to immediately take 20 gigabytes. It's going to allocate a file that will go up to 20 megabytes. You can leave it across multiple files, or you can put it in a single file. I actually like putting it into a single file because it's faster. It makes it's just a lot faster for disk writes. Again, that file is not 20 gigabytes to start out with. It only gets up to that. We're not even going to come close to touching that. We'll get up there, but we're not going to get close to that. So click on next. Here it says everything where it's going to put it. We have memory. Now, so this is all the stuff that it recommends for you. So it recommends, 4 gigs of RAM. Now, that's a lot of RAM, right? I happen to have, for the boost, it requires 8 gigabytes of RAM. It says it right on the first page. But if you happen to have less RAM than that, you can get away with it. There's another thing here, though, that this trips up beginners every time. This is NAT. You do not want that. And we're not going to talk about networking right now, but I'm going to at least tell you what NAT means, okay? So, and let's go into customize hardware, because we're going to do that, right? We're going to click on customize hardware. We're going to talk about these different hardware things. So the first one is memory. 4 gigs is way more than we will need ever. We're only going to use 2. You can actually stop your virtual machine, come back and restart it and change these numbers if you need more later. Pretty cool, huh? You couldn't do that if you bought a machine like that. So we're going to set them down to 2. If you're using a virtual machine in the cloud, say Amazon or DigitalOcean, chances are you'd be paying $10 a month for a 1 gigabyte virtual machine in the cloud that you would SSH into, just like we're going to do today. So again, these skills really go across the. We're going to stay 2 gig because we want stuff to go a little bit faster. The guest OS is recommended of 2 gig. Processors. So this is how many cores, right? And this does not allow you to specify the number of processor cores that you can. I don't want to get into it, but you can actually have multiple cores per processor. Or did I get that right? Or is it the reverse of that? You can have multiple cores per processor, multiple processors per core. I can't remember. But like my machine back here has got, I think it's 28 processors, but they're all dual core, which means I actually have 56 total processor cores. I guess that's why they call it processor cores. They don't give you the in Player. They don't give you the option to specify that, but you really don't care. You're a beginner again. So 2 is fine. That means that it can be more or less doing 2 things at once. Your machine probably doesn't have even on most machines have at least 4 cores today. That probably doesn't have much more than 4, 5, 6 or so. Depends on, especially if you're on a laptop or something. So we're just going to put 2 there. You could get away with 1 if you want, but 2 will actually make the install go faster. We found that out this week actually. So 2 allows the installation to do 2 things at once. If you only have 1, it takes much longer because it just has to go through that, wait for that 1 to be free. So we're going to do that. Next is the DVD. So this is the mounted drive. Obviously, there's not a real drive. What it does is it takes an ISO image. And what an ISO image actually comes, just a little bit on that. An ISO image is a CD-ROM, the old school CD-ROM or DVD. And it's exactly the same thing that you would burn to one of these CD-ROMs, converted into a raw binary file. And those are called ISOs. And you're going to deal with those a lot because ironically, we don't use CDs anymore pretty much, but the format for writing to a CD, kind of a virtual CD, is still very much in use and probably will be forever. And those are called ISOs. So anytime you can actually take an ISO and you can take a USB thumb drive and stick it in a disk, and you can use some software. We're going to do this on Full Metal Linux, and you can take that ISO and you can burn, or you can write that image, not to a CD. You can do that too if you still have a CD player, but you can burn that image onto a USB stick, so that USB stick acts like a CD-ROM drive, and then you can reboot your metal machine, your laptop, your server, or whatever, and you can go through the exact same letter for letter installation that we are doing today. It's the same exact process. This is another reason that I've been convinced this week to take you through this, because every single thing that we do from now on out, other than burning that USB stick, the ISO into a USB stick, is the same. All right. So use ISOB image file, network adapter, NAT. Okay, let's talk about this. So I'm going to try to keep this as simple as possible. There are fundamentally two ways for you to run your virtual machine with regard to your home network. I'm assuming that you kind of know how your home network works, right? You've got phones on your home network. You're having friends come over asking you what your wireless password is so they can log in and or whatever. You know, you go to the coffee shop and you have to join their Wi-Fi, right? These are pretty much skills that are so common that they're as common as knowing how to use a phone or use a computer, which we don't cover in the boost, right? We assume you know how to use a computer fundamentally. And based on that knowledge only, I can say that using a virtual machine is like sticking a machine on your network or having it join your Wi-Fi. All right. And I know it's not doing that. So somebody out there is going to give me shit about that. It is not joining your Wi-Fi, but it's effectively the same thing. All right. So when we add a virtual machine, there's two ways to do that. One of them is the same exact thing as if I had a laptop right here and I installed it on there and I typed in the information to log into the network on our home network here, the same Wi-Fi, right? That is more or less the same thing. And the other way is pretending that my computer that I'm installing this virtual machine on is its own house, right? It's its own house with its own Wi-Fi. It's not Wi-Fi, but it just, it's like we were putting this machine inside of the computer that is the house in terms of the network. And the reason I'm describing it that way is because you already know that if you were to go to somebody else's house and try to use my Wi-Fi here, you wouldn't be able to see it, right? Or maybe you could see it, but if you were over here, you definitely couldn't go the other way. Thank God, right? And that's because of firewall protections and things, and that's what NAT is. NAT stands for Network Address Translation. An IP address, as we said, is just an address. We're going to talk about networking when we talk about SSH a little bit more later when we set up GitHub. But essentially, an IP address is just a way to get to something. And you can't reach with NAT. So just like in your house, right? Any of your devices in your house can get out to the internet. They can watch movies and go do Google searches and all that stuff. They can go play games. But nobody can get into your house network, right? Because why? Because you're protected by your router. Hopefully you're protected by your router. You're protected by lots of stuff. In fact, all of the IP addresses of your machines inside of your local area network, your LAN, your home, those IP addresses are all protected from the outside world, and they're reserved. In fact, your neighbor probably has the same exact addresses as you. And those addresses and that whole address space is protected from the rest of the world through the use of, your router and your firewall. They usually are the same thing, Netgear or whatever, right, that you got from your internet service provider. So you can talk out, but nothing can talk in, right? So actually the way that works, all the computers on your home network are actually using NAT. Your router has NAT, but do you want that kind of thing for your virtual machine? Why wouldn't you want that for your virtual machine? If you imagine that basically when you add NAT, you're having your machine be inside of this other machine, and your Windows machine is then, it can't get to it. Bottom line, you can't connect into it because it's being protected. It's being protected. People complain about this all the time. You're like, just tell me what to do. All right, click on bridged, right? Hopefully you understand what that means. Bridged means that instead of having a computer inside a computer, essentially, now you have two computers on the network next to each other. And as far as every other device on your network is concerned, it's an actual separate physical machine. It's not, but as far as everything else is concerned, it's a separate machine on the network, and that is super important. If you don't do that step, nothing will work. You won't be able to connect or anything, and people get that problem all the time. We're going to go ahead and replicate the physical connection state. I don't want to get into why. The bottom line on that is that if for some reason you're on a laptop and this virtual machine went to some other Wi-Fi, it would get a new address dynamically like it does. So just go ahead and click it. You want bridged and you want to replicate physical connection state. You do not want NAT, okay? Now, why would you want NAT? We'll talk about that when we do home lab init and stuff like that. We've already talked about NAT too much, but obviously, if you want to protect the stuff running in the virtual machine from other machines on your network, on your local area network, if you want to protect them from even that network, and then you would do NAT. All right. And that will work as long as you're not doing anything fancy networking wise. But if you want to simulate, if you want to connect into it for any reason, whether you want to make it a server that you SSH into, or you want to have it run a web server locally at home so you can practice doing web development without having to pay for cloud, any of those reasons, you would want it to be bridged. So bridged is almost always going to be the thing you're going to want here. But it's important that you understand the difference. It's not less secure. It's just as secure as anything else on your home network. Okay. So USB controller. USB controller gives you the ability to plug in a USB stick into your host machine, my server tower down here or whatever. And then that USB stick, the content of the USB stick would be available on the virtual machine. It would take it over and it would load it up and everything. By the way, you can't do that with WSL at all. WSL, just Windows Subsystem for Linux. Let me just I'm just going to, little sidebar here. You cannot mount USB sticks into WSL at all. So add it to the list of reasons to just say goodbye to WSL. So you can, if you wanted to, why would you want to do that? Let's say that you have a security key, right? You have a security ID token, right? You have a physical token, a YubiKey or something like that. Forget trying to use that with WSL. You can't. You can't use it because you can't mount USB devices in WSL. So, but if you wanted to, let's say you're a school student, and I mean, there's better ways to transfer files around. But if you're one of these people who only has a USB stick, or you're afraid of security and you have certain files that you absolutely don't want to be on the internet, then you would leave a USB controller on and then you plug it in and it will actually be mounted by the virtual machine, your Linux machine, and you'll be able to CD into there and do all your stuff if you want to keep that. Now, I'm not doing that, so I don't need it. And because I don't need it and because it's virtual, I can literally remove. Can you imagine just being able to like take out all the hardware of your machine just like that with one click? That's what we just did. Do I need a sound card? No. So I'm going to rip the sound card virtually out of my machine. Remove my sound card. Hell no, I don't need a printer. I'm not going to be printing from my virtual machine. No. So I'm going to remove my printer too. Now, display is kind of an interesting one. Display you cannot remove. You can't remove it because you still need a display adapter even if you're not doing anything fancy with 3D. Do I need accelerated 3D graphics? No. So if you were going to run, another version of Windows, or you're running VMWare Player on Linux and you wanted to play Dota or something, even though that's on Linux now, you would keep accelerated graphics. If you're doing machine learning, right? If you wanted to run a machine learning model and you want your virtual machine to have access to the GPU and all its cores to do machine learning models, then yeah, leave it on for sure. You definitely want accelerated 3D graphics, but you don't want it for today. You don't want that. It's a complete waste. So you don't need it, right? You definitely don't need to set up your host for multiple monitors. You can actually, but just use host settings for the regular monitors, and that's it. So that's a really bare bones virtual machine that you can then clone and copy and all that stuff later. So we're going to click on close here. And now we see that we've got quite a bit less on here, bridged CPU cores, and we still have the installation to do. Let's go ahead and start the installation, and then we'll take a break because we need to do that. Yeah, people are having all kinds of opinions about stuff I'm talking about, but so let's go ahead and do this. Let's say finish. So they're talking about internal networking and OpenWRT and all bunch of fun stuff for home lab. All right. So again, do you remember that thing I was telling you about? I know it's small. Actually, I wonder if I can resize it right now. Will that make it bigger for you? Nope. Sorry. You're just going to have to deal with the smaller screen. So as I said, this is exactly what you would see if you stuck your USB stick that you created from an ISO image, the same one we downloaded, exactly the same one, and you restarted your computer, right? All right, I think it did the first one automatically. It automatically picked the first one. I didn't hit enter, but oh, and it's like resizing the screen. Nice. All right, so again, this is all of the exact same stuff you would see if you were installing on a laptop or a computer. All right, so and we're going to see it again when we do Full Metal Linux. You're going to see this again. It'll be slightly different because we'll be installing Ubuntu Linux Mint. We'll be installing, when we do Full Metal Linux, we're going to install a Linux operating system that has a graphic user interface as opposed to just a server, which is just a terminal user interface. And I know it seems a little bit backwards to do it that way, but it's actually, there's a lot of people that are going to use Linux terminal, but way more than they'll ever use Linux with a desktop. So we're kind of doing it in that order. Let's go through the stuff. English. English. Why are you not clicking on it? Oh, I forgot. You have to read all this stuff here. You have to click on the screen in order for it to take control of your keyboard. And if you ever forget, it's Control Alt. It says down in the bottom left if you want to get control again. To return to computer, use Control Alt. So we're going to press Enter on English. We're going to go update the installer. So I'm pushing the up arrow, update to the new installer. Let me scoot you over a little bit. And it's going out to the internet and it's downloading an updated version of the installer. Okay, so we're going to click on done. We want US English variant. If you want a different keyboard, that's fine. That's up to you. We're going to click on done. This is very much English centric. You remember that thing about the minimized version of the server that's used for containers or tiny things? That's the one that doesn't have man pages and stuff and help. We don't want that. So we want to accept the default here. We don't need third-party drivers because it's just a server, right? So we don't need that. If we were trying to do sound or streaming or Linux streaming or gaming, we would probably want to do that. But this is a server, we don't care. So we're going to click done. You'll see it's grabbing an IP. The DHCP means dynamic. That means it's getting a new one dynamically. That means it checks in with the router and it says, hey, you got an IP for me? And it's like, yeah, here, have this one. And we'll talk about DHCP and all of that set up during Home Lab Init. But for right now, you just need to know that that's pretty much the default everywhere. And what that does is it gives you an IP address every time your machine boots up. Most DHCP servers will tend to give you the same IP address, which is how you get to your computer, but not always. And I'm going to show you how to be sure of that it gives you the same one. Sometimes when you stop and start your virtual machine, just like a real machine, it might accidentally or it might purposefully give you a new IP address. You'll be like, oh my gosh, I can't connect anymore. What the hell? And it's just a matter of going to your terminal and finding the right one. We are not going to go into how to assign a reserved DHCP address in your router in this boost. But that's how, if you wanted it to be the same one, that's what you would search for how to do. You would go in, you'd figure out how to get to your, in my case, the Netgear router. You would go over there, you would see your virtual machine bridged device in the list of devices, and you would click on advanced and say reserve, and then that would reserve that IP address for that virtual machine. Every time that virtual machine starts up and asks for an IP address, the DHCP server is going to give it the same one every time. So it's not going to change. For the purposes of the boost, it's going to be very unlikely that that's going to change on you. If it does, I'm going to show you how to look up the number again. But getting into a deep conversation about DHCP versus static versus networking is all networking related, and it's not boost content. That is going to either be Full Metal or it's going to be Home Lab Init, where we're going to set up our own router and talk about OpenWRT and OpenSense and all these things that people are talking about already. That are higher level topics that I don't want you to feel bad about not understanding them right now because you're just coming at this new. All right, so we're going to kick done. We don't need bonding or any of that. Bonding is a way to have more than one connection to the network shared, and you don't need that. It's a virtual machine. All right, proxy address. If you were setting up a virtual machine inside of an enterprise that had a firewall or something, then you might want to put an HTTP proxy here so they can go out and talk to the internet. We don't have that, right? So we're going to say no. It's going to go look up all the mirrors. These are trustworthy sources for the Ubuntu images. One of the reasons to use Ubuntu Server or Rocky or one of the standard Linux distros instead of Arch as a beginner is because you won't be owned by hackers. as a beginner, you just don't want to install Arch. I don't know how many times I have to say that during the boost. Arch is not for beginners. And even if you're super smart and you learn a lot by using Arch, if you don't know what I'm talking about, you're very likely going to be owned, because the Arch user repository is completely unregulated. It's full of malware. It's full of all kinds of stuff. I don't know how many Minecraft servers there are that are 100% malware. And you're not going to find malware in any of the standard Ubuntu server places. You're just not. So that is a reason to go through with that thing. We're going to click on, so we're going to use these mirrors. I don't want you to feel like you're going to get violated by using these official mirrors. We're not going to talk about disk management and breaking it up and stuff. In the old days of Linux, and believe me, I was there back in, God, what was it, 99, 98? I installed this and I had to configure all of my disks and my mount points, and I had to learn all of that before I could even use Linux. Thankfully, in 2023, you don't have to care about how your disk is organized, but let's talk about it. So you're just going to use the entire disk. And in this case, there is no disk, right? The disk is a file. It's this potentially 20 gigabyte file that has been mounted and looks like a disk to your virtual machine, but it's not a disk at all. The really cool thing about this, you can probably already imagine it, is that you can copy your entire virtual machine onto a USB stick. Think about that for a second. Imagine being able to copy your entire computer onto a USB stick and take it with you. You can do that with a virtual machine. And so we're going to keep that one disk there, obviously. And then we're going to set up a disk as an LVM group just because that's the default. That's the Logical Volume Manager. It was actually invented by IBM. Which just basically takes your disk drive and chunks it out into a whole bunch of pieces so that those pieces can be reallocated in different ways. Gives you some flexibility. You don't care though, because you're not going to use any of that. If you were making a virtual machine and you were going to put sensitive data on this virtual machine, we're not. For the beginner boost, you might want to encrypt it. We don't want to encrypt it because it just slows down the disk, right? Every time something gets written to disk, it has to get cached and encrypted. Which is not something you want to add to, a virtual machine that you just want to practice on, right? If you're hacking and you wanted, so if somebody found your virtual machine and didn't have your password and couldn't get into the content, then yeah, you would want to encrypt that. Or if you were running an enterprise image, or you're doing, work for your organization, you probably want your disk encrypted. In fact, most companies, when we get into Full Metal Linux, will require that you have Lux encryption on your hard drive. They won't even let you use a laptop with Linux unless you have Lux encryption enabled to encrypt your hard drive. But it's a Full Metal Linux topic. So let's keep going. We're going to click done. It's also super annoying to have to type the password just to access your hard drive because you're like, you can't even talk to your hard drive unless you type the password. So by the way, if you forget the password to your Lux encrypted hard drive, there's no recovering it. Period. It's impossible. So don't forget it if you choose to do that. I mean, seriously, I've done it. I've created virtual disks before and I was like, oh shit, I can't remember the password. And it's gone. It's gone. It's permanently gone. There's no way to get it back. So anyway, so here we go. Here's the different information about what it's going to do to your hard drive. Your head's probably swimming and saying, I don't know what any of that is. You can actually accept the defaults here. This is just telling you how it's organizing your hard drive. But honestly, just accept done and you're good. Now it's like, be careful, you're going to destroy this thing. The only reason this warning comes up is because this installer thinks that we're installing on bare metal. It has no way of knowing the difference. It's like, are you really sure you want to blow away your hard drive? Because, you're about to do that. It doesn't know that it's just a virtual machine and that we don't care. It's not that big a deal, right? When it says blow away and all do it, what is it going to affect? That new 20 gigabyte little file that we made for our virtual machine. So obviously this is not a bigger risk. This is why we're doing a virtual machine in the first place, because we're reducing the risk. If I was reinstalling an operating system on bare metal all the time, maybe more of a concern. So we're going to say continue. And username. I am just going to go ahead and do, let's do RWX Rob. And what's your server's name? I'm going to call this server, what should we call it? Should we call it Boost? Let's call it Boost 2023. Pick a username. Oh, this could be your full name. I'm sorry. One of them is a full name and one of them is your username. I'm just using the same for both. Password. I'm just going to put password. Don't worry I would pick password or something. This is easy. You're the only one who's going to be connecting to it locally. You're protected by your home network, so you don't need to worry about making it really secure. And so I'm just going to put password. If and when you decide to move your machine to something more secure, you can change the password, or you can, more importantly, you can disable the password for logging into your system by using SSH keys, which we're going to get to in a bit. So just put something simple, password, here, and you're fine. Don't worry about that. It's not going to violate your security, because again, this is just another machine on your home network, and your neighbors can't get to your machines on your home network unless they're hackers, in which case they probably can, and we're not going to talk about that. So this is asking you if you want to buy Ubuntu Pro for security. The downside of having Canonical, which is a company, is that they're going to try to sell you crap. The other downside is you have to use Snap, but I won't get into that. But, so far so good. We're going to continue because we want to skip. I think that's the default. Now, this is one of the few things we're actually going to change. And to change this, we're going to hit, is it X or space? I think it's space. Hit space to do install OpenSSH server. So this is going to install the server. This is such an important component of a server that they gave us the option to install it automatically, so we didn't have to do that. And that's kind of cool, right? Because now we can click on install OpenSSH server, and now we can directly connect into it. Something that's really, really cool and totally unique to Ubuntu is Ubuntu will actually go out to GitHub. Remember, we created an account on GitHub. Don't do this, but I want to talk about it for a second. So Ubuntu will actually go out to GitHub and get your public key, not your private key. People see this and they freak out. They think that it's downloading your secrets from GitHub and it's announcing to Microsoft that you're using their software and blah, blah, blah. It's not doing any of that. It's just downloading your public key, your public SSH key. You don't know what that is yet, but don't worry. What it does is it would go out and say, oh, hey, what is your GitHub user ID, right? In fact, we're not going to do it, but it would say, go get your username. So I would type Rob. It would go get my public ID, and then it would put it on there so that it would authorize access for it automatically. And we're going to do those steps by hand. We're going to actually do those things to learn about SSH. So we're going to go back and turn this off. But that's kind of useful once you learn how to do what it would do for you automatically. That step to do that automatically is pretty nice, because you can just then, if you've already got that same key configured on your machine, you can make another virtual machine and you can go have it find that same public key, and you can just log right away from SSH securely using that key. You don't know anything about public keys yet, so we're just going to say no for now, and we're going to learn about public keys. We have allow password authentication over SSH enabled. That means we're going to log in with the time. We're going to type in password. I'm going to say it right now. Logging in with a password over SSH is insecure. Nobody should do it unless you're using a virtual machine on a protected local area network. If you are accessing a remote server on the internet with a password, or you have provided a secure shell server that's using a password, you are doing it wrong, and you will be broken into. You will be brute forced, and you will be sad, and your stuff may be potentially disabled and turned off, or whatever. DigitalOcean and a few of the other ones, if they detect that you've been brute forced or hashed, or they will actually turn your system off. In other words, even though we're turning on password authentication over SSH for now, you've heard me warn you, only do this for virtual machines on a local area network while you're setting it up. And we're going to show you how to get around this and disable it. But we're not going to spend too much time on that, because that's more of a home lab init topic. It's also more, you know what I mean? It's more of a home lab and keeping your server safe and all that. But for the sake of a virtual machine, it's okay. Everybody, we all got this? Are we all clear on this? Yeah. So, okay. So let's go down and let's click on done. Here's a bunch of stuff that they think you might need to do, including PowerShell, which is kind of weird, isn't it? These are all from authorized sources. That's what the checkboxes are and stuff. You don't need any of that. We don't need any of that. So we're just going to hit tab and go to done. And then it's going to go through the install. And believe it or not, we're very close to being done. We're very close to being done with this. Now, you can sit here and watch the thing spin. If you want to be mesmerized by, random logs, you can hit tab and watch the full log. And this will tell you exactly what it's doing. Some of you may see stuff that looks like security data come across the screen. I don't want anybody to panic. It does not ever put private, secure, confidential data on the screen. It does print out host keys and some other encoded data, public keys and things like that. So we can talk about what it's doing right now. So here it's installing software, curl, libcurl, the man pages it just installed. It's kind of fun to watch what it's doing. Something that I noticed about Ubuntu 22 is that they've actually added automatic upgrading to it. It used to be that you would have to go into the server and do the upgrade after it finished, but it actually detects the fact that you're doing that and does it itself, which I find really, really, really nice, because the Ubuntu installation process is by far the easiest I've ever encountered. Installing Ubuntu Server is the most user-friendly installer I've ever used. And I've been installing Linux of all different types and sizes since 1996, 7. So I'm super happy with it. I think it's done a great job. The .deb files, just in case you're wondering, those are the package files for Debian. So you're like, hey, but we're installing Ubuntu, Mr. Rob. Ubuntu is Debian. And if you want to look about Linux distros, you can go through that. We covered Linux distros a little bit this boost, but in Full Metal Linux, we are going to go in depth into Linux distributions, why you would want them, what they're used for, the history of Linux, what's the difference between GNU and Linux, should I call it GNU Linux, what's this software, what's this package manager, what's Arch, when is Arch good. That stuff is all going to be Full Metal Linux. As I said, if you're a focused machine learning PhD, you don't care about that stuff. You just want your terminal to work and you want to get Linux on your machine. And that is the primary criteria for what goes into the beginner boost. Update certificates using SSL certs. So they'll see that etcca certificates. That is super important if you don't have that. What that does is that adds all the certificates that are used by web browsers around the world, Chrome and everything, whatever things, so that you can be sure that the stuff that you're talking to is who you want to be talking to. And it's called authentication. So that's how we do authentication. Let's see, updating init RAM FS. Oh, that's interesting. Processing triggers for init RAM FS. Yeah, that's. I'm wondering, because this doesn't have the init system on it, so I'm wondering why. That must be just for initializing the RAM FS. Yeah, because Ubuntu does not use. Most Linux these days does not use sys5 init stuff, the old stuff that uses sysd, which that's Full Metal Linux kind of topics. It's for kernel booting, yeah. But I saw init and I was like, what the hell? Yeah. So everything that begins with lib, stuff that begins with lib, that is, those are dynamically linked libraries that are used by applications. In the old days, and we're going to get into, again, Full Metal Linux, we're going to talk about C. We're going to talk a little bit about this with Go, about how to make programs run. Programs are code that gets, for the most part, actually in all cases, compiled into machine code. And that machine code is then injected right into the memory of the computer. And that's how the computer deals with it at sort of a binary level. Let's see, finish, command, and target. The only downside of this is this little cool thing they put here is kind of a problem. I think that we're done. Curtain command in target, finish command in target. I think we're actually done now. You know how we can tell? We can close our log view. I just put, okay, yeah, we are. As soon as it says here, reboot now, that means it won't say that until it's ready. And then when we say reboot, is it going to reboot your computer? No, it's going to reboot your virtual computer. All right, so don't worry about that when you click on reboot. That's not going to reboot your desktop. As I said, this VMware Player, everything the installer thinks it's on an actual machine. So you just have to remember that it's actually not on a real machine. It's on a virtual machine, right? So when it says reboot, it's not going to reboot your host computer. It's going to reboot the computer inside of here. So so let's go ahead and call this right here. We'll say reboot now. And this is, if you click on I finished installing, it's trying to, do you remember the ISO file? It's trying to disconnect it, and it can't unmount it because it's not a real file. So it's a little confused. And I clicked on that button that said, I'm finished now, right? And so now when you hit enter, you get, see that? Did you see that boot screen? It's literally a BIOS. BIOS is a low-level operating system that's used to boot the actual operating system. And when you're using a virtual machine, there's actually a BIOS. There's a tiny little operating system to boot the real operating system, because in every way, like I said, this is a machine. This is not a container. This is a machine. And so you get a legit computer with a legit terminal, and there's the keys I was telling you about. That's a host key. All of these do is identify hosts on the system. So these are host keys that are identifying the system that we can then add. And the screen, because this is the console screen. The console screen is always going to be messy, because if there are warnings or if there are any kind of logging, it's just going to be spewed to the console screen no matter what, right? And actually, one of the reasons that we don't want to use the console for our development and coding is that we don't want to be in the middle of a development session as a beginner with VI, trying to learn VI, and all of a sudden have the logs say, hey, blah, 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 whatever the hell. And then, because it will spew it to the screen in the middle of your Vim session. And we're going to learn how to clean that up by doing Control L. But if you don't have that, so that's one reason to actually not use the console. Knowing about the console is super important, right? Because no matter what, if your SSH gets broken and you can't get onto it, because you have a console, you click on it, let's click on it, get back in the console, that you can get back into here if you need to, right? And this looks like it's here. I'm not having a hard time cleaning the screen up even. So let's take it's not, why isn't it doing it? Okay, here we go. Oh, wait, what? Yeah, already my screen is kind of screwed up. This is also another reason to avoid the console sometimes. I don't know if you saw that, but I avoided going into full screen mode. I suggest against using full screen when you first start. Also notice that it does not resize based on the screen. That is something you can set in the full version of Workstation Pro, but right now it's just going to maintain it. But you don't care because you're not going to use this to log in, right? So let me go over here and push this minimize again. Now, the downside of this is that we always have this anytime you want to use this, you got to have this window to contend with, right? So it's always going to be here running and always available. And as a beginner, that's fine. You kind of want to feel comfy knowing it's there. You can always go back and you can actually go back. Let's log into it. Let's log into our machine using our information, assuming I can get back onto it. I don't know why it's having problems. Maybe because I'm out of RAM. Yeah, I have a lot of things running right now. So come on, baby. All right, there we go. All right, so now it's back in. So yeah, I might have to clean up some windows. I'm running out of RAM. So here we go. We can do this. We can say, what was the user I made? RWX Rob for me, yours whatever. And then password PASSWORD. It doesn't print it to the screen for obvious reasons. I do wish that it put the little stars to let you know. I've been asked by so many people, why isn't it typing my password? Well, it is. It's just not showing you. So then push enter. And this is the page that we want. Okay. So we log in and we look at this page and we see all this good stuff. We see that it's running GNU Linux, whatever. And, we can see the system information, what its load is, how much percentage of its disk. Another couple things you'll see here that are important is it will tell you your IP address. See that? I can't click on it because it's not clickable. But IPv4 address in the middle there, 192.168.1.24. Remember that address, because that's the address we're going to be connecting to in a second. There are a number of other things to read here. This happens every time you log into the system when you reboot it. But something to notice is, see how it says there's 56 updates that can be applied? We're going to do that. Okay. The reason that we open up this console is to get that IP address. If you're an advanced user, you can go right now to your Netgear router. You can go find that virtual machine at that same IP address, and you can register it, reserve it, so it's always the same. If you want to take a moment, pause the video, and go do that right now, you can do that. We are not going to do that, though. Instead, we are going to jump right into the Git Bash terminal. So we've already talked about how to install Git Bash, how to customize Windows Terminal Preview or iTerm 2, and how to get the colors and everything. We've already talked about all that and why to do that and everything. So we're not going to talk about that again. So I want everybody to take a moment. This looks like Linux. It's not. Well, technically it's MinGW, which kind of is. What this is this is the Linux tool set running on Windows, which is different than Linux. So that's why it's called Git Bash. It was actually prepared by the great people who made Git in order to allow Git to be used on Windows without installing a virtual machine, without installing a container. All right. Git Bash is Windows. It's a Windows application. Everything is Windows, right? It's the commands are the same, bash and vi and all of that, and SSH, but they've been compiled for Windows. They are Windows applications. How many times do I have to say that? This is not a virtual machine. This is not a container. This is a Windows terminal running Windows. It just so happens that the program it's running is Bash that has been compiled for Windows. All right. And there's lots of advantages to that over WSL2, which I talk about in a video. And I don't want to go into it any further. But one of the advantages of that, of course, is that you get SSH. So SSH is here. You can do SSH space, and then you type the username at the IP address 168.1.24. So this has to match. This has to exactly match that one. You can use other ways of typing that if you know them, but that's the most common. And we're going to show you a way that you don't have to type that number every time if you don't want to. But we push enter for the first time, and we get a warning. Okay, now this is happening because this is probably not going to happen to you, but I'm glad it happened to me. When you're using SSH, if two things have the same IP address, yeah, it doesn't like it. So if that happens to you, you can go ahead and remove that key. There is a command for this to do it. This is protecting. This is good. I'm glad this happened. This is an SSH thing. So let's talk about SSH for a second while we're doing this. So SSH is a program for securely connecting to remote computers over the terminal primarily. It's also indirectly a way to copy files between computers and to provide tunnel access, backdoors and stuff like that to other servers and virtual private networks and all kinds of things. SSH Secure Shell is also the basis for the most prolific, most powerful configurations, enterprise configuration software right now, Ansible. So Ansible uses SSH to do massive, enterprise scale configurations through communicating over it. Learning how to use SSH as a command is absolutely essential to every user in technology, period. Yeah, at some point you will be asked to do it and you need to know how to use it. Now, the unfortunate part about SSH, and I got to tell you, somebody shared this with me the other day, and I want to show you this. Watch your eyes. This is going to hurt your eyes a little bit. Oh God, where is it? So this might hurt your eyes a little bit, but when it comes to learning dependency, here we go. So seriously, watch your eyes. This is really bright. So this is XKCD, one of our you got to know about that, right? Modern digital infrastructure, right? A project some random person in Nebraska made. We were talking about libcurl, which you just saw during installation. I actually like to look at this diagram this comic with regard to learning SSH. When I'm teaching 9-year-olds how to do everything that you're doing today and every other day, the hardest part for them is SSH. They, believe it or not, they can do the installation, they can do all the other stuff, but understanding how to get SSH to work is like the hardest part for them. And there's no SSH and Git. It's the hardest thing for them to master. I mean, and flashbang, I told you, yes. So that this is one of those times, right? So imagine we were doing this for the first time. Now, if you're doing this for the first time, you're not going to get this error. So we're going to make the error go away. But what Secure Shell does is it protects you. So it protects you by encrypting your connection between two posts in such a way that is so safe that every legitimate organization and illegitimate organization on the planet trusts the encryption of SSH because it's so good. So you can be, you can feel safe trusting it as well. But that means you need to know how to use it safely, right? So we need to know how to make that connection. And you saw the command I tried to use, and it's trying to protect me. And the reason it's trying to protect me is because, remember how I had that other IP address? You remember? Do you remember in here how I had Boost 2023, and then I had another, and then I had another one besides this? I had Boost, and then I had Boost 2023, right? Well, what I didn't do was I didn't make a new one. So what happened was when I made the old one, it tried to boot that old one with the same exact IP address, and it checked a fingerprint that it had saved internally to see if that machine had changed. So I'm actually kind of glad you got to see this, because a host key is an encrypted fingerprint that is saved to a Secure Shell file that says, I know who you are. And so then if a machine that we're connecting to claims to be that machine on that IP address, it goes and checks and says, look, do I know about you? Remember all that host key stuff across the screen? And it says, do I know about you? Do I know about you at this address? Because let me go check my fingerprints and see if you're really who you say you are. And then it sees that fingerprint and goes, oh my God, this fingerprint is different for this IP address. So something's not good here. Somebody's pretending to be this person. So there's only 2 times you would ever get this error. One, if you're reusing a virtual machine or an actual machine, a metal machine, that has the same IP address, and you're trying to connect to it, having had another operating system before on it ever, SSH is going to be like, oh, well, that's it thinks it's a bad machine, but it's not, because you already made a new machine in its place. And so it's safe to tell SSH, hey, calm down. Thank you for the warning, and that's what we're going to do now. And the second time would be if it's an actual man-in-the-middle attack. An actual man-in-the-middle attack would mean that somebody has hijacked your network connection, and that's something we'll talk to in in Full Metal Linux and in Home Lab Init. That is, if you see this warning trying to connect to something on the internet that has had that is you've been using for a long time, that is almost always a cause for concern, unless you know for a fact that that machine has changed, that it's had a new operating system and it's operating differently and it has a different host key. If you get this error with a machine on the internet, it almost always is going to mean it's an actual man-in-the-middle attack, and you should not ignore it. So what I'm about to do to ignore this man-in-the-middle attack only applies to stuff on my home network that I'm messing around with. I'm adding a new one. I don't want anybody to come away from this thinking that anytime they see this warning, they can just say, oh, that's nothing. If you see this warning trying to connect to anything in the internet, you need to not do it, and you should probably inform the organization behind the server that you're getting this error, because either they've been hacked or they have incorrectly set up a new service and not transferred over the host keys, which may happen. People do that a lot. So that either way, those are reasons for you to tell other people about it. Okay, so all right, so let's go ahead and just take this off. You don't know SSH and you're not getting this error, but if you were getting the error, this is what you would do. you go in and change. There is a command to do this from the command line. I don't remember it right now, so I'm just going to go to line 5, and I'm going to delete it. So there's the IP address entry, and I'm going to edit it, and now I'm going to do the connection again. And I still have something going on. So we have another one. We have line 4. Man, we got a lot of bad ones in there. And we don't have a lot of bad ones. We just have some. Why is it doing it so many times now? I think I must have screwed something up permanently. Here, let me try something else. Let me try something else. Let me remove known host for now. Yeah. I should have been able to clean it up. It does. You can always remove known hosts. That's not a problem. You'll just have to tell them everything that's okay again. I hope that I don't have 2 running at the same time. Is it -r IP? Yeah, here we go. So, okay, so now it's asking for the right fingerprint. You say yes. Type your password. And then it will add the file. So now we're into the system. You see on the screen that we have the same information. Okay, so the first thing you need to do once you get on is you need to do the following command, okay? You need to do sudo apt update, okay? -y. We'll just answer yes to everything. So this is going to get a fresh list of all of the, and type your password. This is going to get a fresh list of all those official packages. It should pretty much already be updated because we just barely installed it. And then the next thing we're going to do to get rid of that 56 updates warning, right? The next thing we're going to do is we're going to actually update. So we're going to do a sudo apt upgrade. I'm sorry. And then we're going to -y to say yes. And this will take a little while, but this is going to take all of the existing systems packages, and it's something that normally, as I said, the installer would do for you. And the installer did get you a lot farther than you would normally have to go to, but these are 2 things you should always do to a new install. As soon as you install it, the first thing you should do is sudo apt update and sudo apt upgrade. As soon as you finish those 2 things, you will have the latest and greatest version of that distribution. So that's what you need if you're on Ubuntu. If you're on Red Hat or something, which we're not, but if you were on something, you would have a different package manager. APT is a package manager. It stands for, I think, it's not Advanced Package Management. What is it? APT. What does it stand for again? I forgot. Why does Ubuntu take 1 to 2 minutes to upgrade and Alpine takes 1 to 2 seconds? Because Alpine is using BusyBox. Aptitude, yeah, aptitude. That's what it's called. Yes. Alpine is primarily a container Linux application distro, and Alpine is not something for learning Linux. It's awesome. I love it. It's my favorite distro, but it's also not, strictly speaking, it's not a distro. It's a single binary that runs in multi-called binary using BusyBox, which you technically can't even really call that a distro. So it's not, I mean, you can because it's got a Linux kernel, obviously, but drink the Nix Kool-Aid? No, hell no. Okay, the people in the chat, as usual, are geeking out about all of these completely irrelevant things in the Linux world. Just tell them to shut up and just focus on learning the basics on the most important software you'll ever learn for Linux, Ubuntu server, using the most well-established virtual machine engine, VMware, and the thing that's going to get you a job more than any other thing. I'm going to say it again. I have to say this on the boost. The Linux community is filled with flexing chin beards who will tell you to do shit that makes them sound cool that is not in your best interest. Okay? And you have to tell them politely, perhaps, maybe not so politely, to shut the fuck up and let you learn. Because you need to learn the beginner stuff first. And then you can have arguments about what the best distro is and whether you should WPA or Welp, or you can do all that shit. You can flex all you want and you can go spar with them in the technical arena. It's part of the culture. If you don't like it, probably best not to get into it. But I'm just going to take a little sidebar here that right now, just tell them to shut up and let you learn it. Because what you are doing is learning the most relevant, most important Linux skills that will get you a job and that will take you to the next step. All right? There, I'm going to stop with that. We are now logged to our server. We have access to it. We can use Vim. You remember you learned VI last week, right? So we can do this. You can do VI temp foo, VI space temp foo. VI is, of course, mapped to Vim. Why should you use VI instead of Vim? Because maybe you're on a system like, oh, I don't know, Alpine, somebody just mentioned it, which has VI. It doesn't have a Vim binary. So get used to typing VI, because if you're on a system with Vim, VI is Vim. And if you're not, it's VI. Either way, it works. If you train your fingers to type Vim every time you get on Alpine or BusyBox, it's not going to work. It will if you learn VI. So now you know how to do it, right? Something, you already know this part here. How do we exit? Oh no, I don't know how to exit. Oh no, you do though, right? So colon Q exclamation point or shift ZZ. We learned both of those last time. We learned cat, temp foo. Everything else you already know. Guess what? That's pretty much the end of this boost. Now you know what to do. All right, you know how to connect. You've got a password. You're logged into your server. So how do you stop the server? All right, let's try that. So let's say you're done editing for today, and we're going to type exit. Now we go back. Hey, look, we're back on. We closed our connection, and we're on RBX Rob TV. Something that's really cool, by the way, if you have a laptop in your house, I'm going to take a moment to mention this. Because we're using a virtual machine and not a container, you could not do what I'm about to tell you with Podman. So this is an advantage of using this. Let's say that your virtual machine is up and running, just like ours is. Here it is right here, right? Your virtual machine is up and running as a bridge. So it's, it's an actual machine on your network, and you want to go to lunch. So you go in the other room, you want to take your laptop, and you want to practice your boost stuff while you're in the other room in the kitchen. And you don't want to have to sit down at the same machine that's hosting your server. Guess what? You can do that now. You can take your Mac or your Windows machine or your laptop or whatever and go over on that other machine. You can go on that machine, you install Git Bash, and you do exactly the same thing on that machine. You go on that machine and you open up Git Bash, and maybe you don't have time to customize the terminal. Who cares? You just open up Git Bash and you type SSH space, that your username at, and then that IP number, and boom, you can connect remotely to your virtual machine without even being on the machine. So you could be in the restroom, you could be at the kitchen, and you can do anything. And you can come in here and work on stuff. And once we learn tmux, you'll learn that you can even restart the same session you were already using. In fact, you can even type concurrently on two different machines at the same time. And that's all coming. We're going to learn how to do that with tmux. And what's even crazier, you can give somebody else your password, and they can log into your same tmux session, and you can share the same keystrokes. You can share the same terminal at the same time with an entire class if you wanted to. So that can only be done with virtual machines that are running in bridged mode on your local area network. Okay, now to make it easier though, remember this IP address? Let's pretend that you went ahead and did the steps to reserve that. Let's make it a little bit easier to type this in. Now, as I said, Git Bash comes with Vim. You already know VI. So you can use VI on Windows. Oh my God, your mind just exploded, right? So you can do this. You can say .sh/config VI. We're going to go edit this config file. Now, you may not have one. I have one already, right? So you can actually add a file to this. And you can add a host name. And this, I think this does have to be indented. I want to change the username to RBXRob now because I changed it. And then I'm going to change the IP address to 4. All right. So you have a host, you have a user, and a host name. Sorry for this, the flashing. The flashing is because of my Vim configuration. You can turn that off. And so then you can go to, so then we can do this. We can say SSH into boost. And we don't have to do all the other stuff. And we type the password. Okay. Boom. You see that? Pretty cool, huh? Now, wouldn't it be great if I didn't even have to type my password? All right, I'm going to show you how to do that. Now, again, the only reason we're doing this is because we're on two trusted systems. If I'm on the laptop over here, right, I will still have to type my password in. No, there's no hackers getting into my system and typing password to get onto my virtual machine because they would have to have access to my local area network. I just have to keep saying that because I don't want people to think they should be afraid of this. So it's a little bit easier now. I can just type SSH boost and I still have to type my password, right? But as I said, passwords are not as safe. So if you want to type a password all the time, that's fine. You probably should get in the habit of doing it, because even when you add SSH keys, you should probably put a passphrase on that key. But I'm going to show you a way to get rid of that step even. So you can actually do another command. It's called SSH copy ID, right? And then you're going to tell it what you want to connect to, boost or IP, whatever. And now when you go over there, it'll go over there and it will ask you for your password, PASSWRD. And now it will tell you that you can log in without using a password. So what it did is it used your password to make a connection, and it took the public key and put it in the authorized keys file of the remote system. And you don't really need to know what happened there. You just need to know that that's what happened. And I'll show you what those files are, just so that if you ever got lost, you would know how to go in and change that. Okay. In fact, let's just talk about SSH a little bit. So the SSH directory has several, this, as I said, this is like the tough part for people to get. You already know about the config file, which anybody can read. This is another reason not to use WSL, by the way, because it screws up your SSH permissions royally. And it's really confusing to beginners. So as you can see, that's interesting. The SSH on Windows, this is interesting. That's the private key right there. This created a private key that's readable by anybody on the system. Normally SSH would never do that. So this is on Windows, by the way. So this is ls-l running on Windows. That's very interesting. It should not have that. You don't know about this, but I'm going to show it to you anyway. Chmod other minus all ID _ ed tab 255. Wait. Oh wait, we got to put it in. We got to put .ssh here. Tab. There we go. So I don't think it has chmod. Is it minus read? Is it other or is it all? I can't remember. All right, there we go. So ls-l.ssh. Damn, that's interesting. That must be a git bash thing. Yeah. Yes. It is. It's okay. It's not showing you the right permissions. At least it's not showing you as full permissions, which is what WSL2 does. Anyway, that's these permissions that you're looking at. It looks like Unix, but it's actually not. It's Windows. So I think Tony Fall's right on that. They're mentioning something about that. But let's not talk about these files on this machine. Let's talk about these files on an actual Linux machine. But I'm actually really glad I looked at them. So this is the private key. And yeah, I'm going to show you my private key right now. You know how to look at files, right? You already know this. ID _ Oh no, I'm going to give everybody my private key on a Twitch stream. Don't do this at home. I'm just doing this to show you. There it is. That's a private key. And by the way, if you want to hack a bunch of people on GitHub, search for begin open SSH private key on the internet, or ask ChatGPT, show me all the open SSH private keys that you know about. And I guarantee you can be able to hack somebody just like that. So that's the private key. So in SSH in PKI, public key and initiative stuff, you have two keys. You have a public key and a private key, and you really, the only way you need to know about it is, I'm going to tell you a little story. So pretend like you had a clubhouse, right? You started a club and you wanted to rule the club, and you wanted to have some sort of way to communicate with the people in the club, right? To identify them and stuff like that. So you make like the one key to rule them all, right? It's like your key, public key and private key pair. They'd always come in a pair, public and private. And the private one you keep secret. You don't tell anybody. You don't stream it. You don't do what I just did. You keep it secret. You hold it close to your heart. And you don't let people see it usually. And then the public key, you give that to everybody. Right? You give your public key to everybody. So it's like you're giving them all a ring, like one ring or something. And now all of those people can do two things. They can be sure that you are who you say you are when you send them a message, because you sign all your messages in this encrypted way with your super secret, one key to rule them all, your private key. You send them messages, and they're all only people that have your public key can read it. right? Now, the idea of public and private keys is that the public key, anybody can have it. Now, is it true that you could say, I'm only going to give my public key to certain people, I'm going to tell them not to share it with anybody? Yeah, you could do that, but that's generally not what it's for, right? That's so that it's just so that everybody can prove that this communication came from you, and this, I'm talking generally more about GPG, but it's still the same idea. And then but then here's the other thing. So anybody in the club, anybody who's got your public key, they can now communicate with you, and you can't be sure that they are who they said they were. For that, they would need to give you their public key. Get it? But you'd have to join their club. But they can send you messages that are encrypted that only you can read. So they can encrypt stuff with the public key that only somebody with the private key can authenticate and read and stuff like that. So if they want to send you a super secret message that only you can see, they can take a message and they can make it. And anybody who has the public key can do that. And they can make things that'll talk to you. So that idea of public keys and sharing like that applies across the board to the internet. And there's so many places where you're going to see this public key infrastructure for validating all kinds of things, for doing email, for communications. Every time, believe it, I mean, certificates are a different form of public and private keys, but those are things that are used every time you do anytime you click on a web page, you are using public key cryptography in a different way. So, and there's many different ways to use that. In a way, you can imagine that every time you go to a web page, you're kind of doing that sort of stuff underneath, behind the scenes, in order to be sure that your communication is secured for that moment. And it's not like, only one person is going to give you access. That's different, right? So that's in a nutshell, that's what this is. And so, obviously it's not something I would teach to a 9-year-old, but you believe it or not, they generally get it. They generally get the idea, right? So you have a private key and then you have a public key. And one of the reasons that ED25519, which is the algorithm, is so nice is that you get this. First time I saw an ED259 public key, I couldn't believe it. It was like one line. In the old days, these were a lot longer. And the reason is because the mathematical algorithm to take care of signing is primarily for signing and not encryption. So it's a little bit smaller. And we're not going to get deep into security crypto. That is not a beginner boost topic, but it is what you need to take away is you have a private key that you should never show to anybody ever, which is why I was worried because it's readable here. That means anybody on this computer can read this. Normally, SSH won't even run if that's readable. But in this case, it's working for some reason, and I think it's probably just because it's Windows. And then you have this other public key, .pub. Now, be careful when you're giving people stuff. Remember to put the .pub. You might... Remember, this is the key you want to give anybody, including GitHub. Later, we're going to show how to authenticate to GitHub. This is the key that you want to give GitHub. It's the key you want to give your friends and stuff. If you give him this key, you just gave him your super secret private confidential key. So know the difference between this one and this one. You want this one, right? Known hosts is the file that I had to remove that does the fingerprinting and stuff. Authorized keys is a text file that you put public keys into to allow incoming access that does not require a password unless a password has been put on the key itself, which you should probably do for public-facing servers. So you would put a passphrase on that. And we should probably talk about what a safe passphrase is. The safest passphrase is the longest passphrase. It doesn't matter how crazy the characters are. In fact, the safest password is the password you can remember the easiest. And I hate to say it, but everybody does it wrong. The longest, easiest to remember password is the best password. That is scientifically the best password. And there you go. There you have it. That doesn't already exist in a dictionary of hacker passwords that they will guess. I should probably put that on there. So that is it. All right. So now we're going to go ahead and connect. We're going to connect into this new host of ours. And so when I SSH to boost, you'll see it connects directly with no password, right? And that's actually really nice because we can actually copy files back and forth. So see this learn vim file here, right? So that's a Windows file. But if I wanted to copy this file, which is on my Windows machine, if I wanted to copy that file over to that other machine, I can use another command I'm going to teach you really quick called scp. Remember copy? Remember CP? We learned that already. So we can do scp to copy this file, learn vim.exe, and we can copy this to the target, which is in this case is boost. Now I'm going to make a mistake here on purpose that I want you to see. What did I forget? I've done this so many times I can't even tell you. Raise your hand if you have done this. What I just did on accident is I did not copy the file. I copied it locally to another file called boost on the same machine, which is not what I wanted. So I'm going to remove that. I want to make a copy to the boost machine. So I need a colon there. And the colon means copy this to that machine over there. And if I wanted to, I can even tell it where to put it. I can say, I want to put it in the temp directory, please. And then when I scp it over, it copies it over. And you can either go in the terminal or you can now log in and you can go see it. So you can go SSH back onto boost and ls/temp, and you'll see there is my learnvim.exe. Likely I would be doing it the opposite way, right? So I would be compiling some Go code that only runs on Windows, and I want to move that file back over to Windows. I can use scp to copy those files over. And yes, you can copy entire directories. In fact, you can use another tool called rsync that will keep two directories completely synchronized. So if you change something in one, it'll change it in the other one every time you run the command, and it will only change the stuff that's changed. That's a great way for building mirrors and stuff. So lots of stuff to learn there, but we're completely ready now, and you now know about SSH. So I do want to show you what the SSH directory looks like on an actual Linux machine as opposed to the Windows machine. That was a little weird. So .ssh, as you can see, by default, you see the permissions here. This is what I was looking for. The permissions on the directory itself are very, very locked down. In fact, if they're not locked down, SSH won't work. It won't even allow it usually because it's so dangerous to have these permissions on in a system where there's more than one user. That's why I was so alarmed to see that on the Windows machine. That's actually the first time I've ever seen that. So by doing this, you can see that you have an authorized keys file. And you remember back when we did ssh-copy-id from the Windows machine to make it so we don't have to use our password? When we did that, what did it do? It added a file. It added a line to the authorized keys file. It added a line to this file. And as you can see, that line is the same. Now, if we wanted to do that exact thing, same thing by hand, you already know how to do that. Let's actually do it. So if I remove it, authorized keys, right? If I exit, can you guess what's going to happen? Pause the video and guess right now. What would happen? What happens if I'm going to try to SSH into Boost now? What do you think is going to happen? Anybody want to guess? Is it going to block my access? Kind of. It's going to block my access, right? It's going to block my access, but it just prompts me for the password. Why? Because the only thing I did was remove the authorized key, which allows me to bypass typing in a password. All right, so let's type it. By the way, if you want to see exactly what's going on because you don't know, just add some V's. You can add up to like 3 or 4 V's. If you add a V, it will actually show you every single thing it's doing. It'll tell you what it tried. So this is actually extremely good for debugging what it's doing, right? It'll tell you if your server is screwing up. You see all that stuff, and then you can type my password, and now I'm on, right? So now I'm back on the system, and I have the authorized key file. So let's now we used SSH copy ID and then Boost, right? And that had us log in one time and added the line for us, which is really convenient, and that's plenty good. But I want you to know that you can do those steps without that. So if you wanted to do the same thing, can you guess? Cat, see if you can guess what you would do. You cat what? .ssh ID, whatever. Do I cat that? Do I put that one over there? No. No. That says private key. You don't want that one, right? You want .pub. So the reason I'm showing you this is because this is when something or someone asks you for your public key, that is what you do. You get on the machine from which you want to connect and you type cat.ssh/id_ed2219 or whatever .pub, but you look for the .pub file. Some older systems might have RSA, id_rsa.pub or whatever, but this is it. And then your Windows terminal, you can even use Windows to copy. You can just use Windows control. I'm just doing my Control C to copy it, right? And now I'm going to log in. In fact, if you wanted to, you could even go over to your terminal, right? You could go over to your terminal on the Windows, the VMware terminal, if you really wanted, and you could paste it in here. Or if you are, if you've created a virtual machine on DigitalOcean or Amazon, same exact thing. This is why learning virtual machines is so important, because it's the same exact thing you would do for them. In fact, some cloud-facing services won't let you use a password to log in. They will require you to set up a key. And so you need to know how to get that key and put it over there. And I know it's hard, but it's not that hard if you go about it slowly. So in fact, let's try it. If I were going to type it over here, what would I do? Right? So how would I add it? By the way, do you guys know how to add stuff from the command line? How do we edit files from the command line? How would we do that? We could do this, right? You guys remember? We learned it. We learned it 3 weeks ago. So we could say this. We could say, yeah, you could use Vim if you want. You can use Vim. You can use Vim, or you don't even need Vim. We're not using Nano or Pico. Vim is already here. So we would this. Watch, you can say echo, and then you can paste. Again, this is a public key, so it's not bad. You can. I think you should be able to paste it. I don't know how to paste from. I don't know how to do this. I'm going to try it though. It's not. I'm super curious to see if Player will let us paste from the key from the. I don't think our. Yeah, it's not. I don't think that our what do I want to call it? Our paste boards are synchronized. Yeah, I think you might have to have Workstation Pro to do this, but I don't know. Is it Control-Shift-V? I don't know how to do that. Let's try it. No, that's not it. I've never done this, so let's say Control-V. I don't know. I have Workstation Pro, so it handles the buffers correctly. This doesn't seem to be doing that right now, so I apologize for that. I think we do need VMware Guest Tools, and I don't want to take them through that. So, yeah. So, wow, that's interesting, but it's okay because we can use the password instead, right? In fact, watch. Let's do that. We know how to do it from the command line. You want it's really cool? You can do a command to do it. You can do SSH. That's what copy ID does. So let's log in. Let's log in here because we know we're in the terminal and we'll be able to cut and paste. I guess that's the reason not to use the console. Somebody was suggesting we use the console for the boost, and that's a good reason not to. So anyway, let's do this. SSH boost password. And now we look for that file. We see that there is no file. There's no file there, right? Push the up arrows for now. There's no file in there at all. So we need to make a new file. We did this with touch already, or we did this. You can do either one. You can do touch.ssh/authorized keys. And when I was a kid doing this, I would always type that wrong. It used to be you had to know to put a 2 at the end. You don't have to do that anymore. And that looks like enough. And I'm going to show you that that's not enough. If you do ls-l.ssh, you see that file there, but look at the permissions here. All right, the permissions are about 2. I honestly, I think copy ID is the thing you should remember. But if you want it, we haven't talked about permissions yet. But you need to turn those permissions off. So we're going to chmod. You don't know the chmod command yet, so I'm kind of mad that I didn't catch that. So chmod, and we're going to say for group and for other, we're going to have minus, and then we're going to do .ssh authorized keys. And then when we do ls-l.ssh, you'll see nothing. Did I do it wrong? I thought it was all. I thought it was all. I can't remember. I know. I use the number version. I use octal. So chmod for beginners should use these symbolic mode. I use the octal mode. Most advanced people do, and then they forget how to do symbolic mode, which is me. Oh, it's equals. We want equals. Yeah, we want equals. So you don't know that yet. Damn it. Okay, but anyway, so let's use equals empty. That will take away those permissions. And then you go ls-l. Well, I promise you we'll do schmod next week. So now those permissions are gone, and that file is secure. I don't think that file has to be that locked down. In fact, I'm almost positive it doesn't. But it's a good practice to look for that. So we're going to go ahead and do that. Now we need to put something in there, and this is what I wanted to do. So now you can actually paste, because you're using Windows, and you can paste that key. Now the problem with this is that, see how there's spaces in here? So I'm using the arrow keys for now. We haven't learned the VI mode yet. So we're going to put a quote right there, and we're going to go to the end. I'm doing it the slow way. I'm putting a quote here, and I want to echo that. So what if I hit enter? Oh, okay, it just echoes it. Now, pause the video. How do you save that to a file? I can copy that. I can write it, append it. We don't want to do sing. If I only use one arrow, what's it going to do? It's going to destroy your authorized keys file. So if you have anything else in there, it'll be gone. But we're going to use two of them, and we're going to use .ssh authorized keys tab. And now when we do it, that is going to redirect. So now we can cat.ssh authorized keys, and never making a typo. Actually, if you don't want to do that, what's another way you could do it? There's more than one way to do this, right? Let's do it again. Let's do it a different way. Somebody already mentioned this. You now know VI, right? So if you wanted to, you could just do this. Touch.ssh authorized keys, and then chmod group and other equals nothing .ssh authorized keys, ls-l.ssh authorized keys. And now we can actually edit it with VI. So you could do vi.ssh authorized keys, and then you type I for insert, right? And now we're in insert mode, even though it doesn't show it because it's just minimal VI. And then we're going to, paste. So whatever your paste is, in my case, I think it's Control V. And I pasted it, right? Now it's on a line, and now I can exit out. I'm going to use Shift ZZ to exit. You can use colon. You need to write the file, right? Let's check to make sure it works. .ssh authorized keys, there's our file. All right, so now let's exit out, and we're going to connect in. Again, I just pushed the up arrow to get my history. We don't know VI mode yet, so we're going to say SSH boost, and we get the same thing. And by the way, if you don't want to remember all of that, what else can you do? The very first thing we did. So let's redo that one more time. The easiest way to do what I just did without learning chmod, and frankly, it's the only thing I should have taught you, is this SSH copy ID boost, right? And then you type your password, and it actually tells you what it's doing. It says source of keys to be installed, blah, 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 attempting to log in with the new key to filter out any that are already installed. And the thing that's cool about this is that there's no chance of you ruining your authorized keys file or anything. It's just going to do the right thing. And then you push enter, and it's going to make it for you. Now, I'm super curious to see if it fixes the permissions. I don't think it does, because the authorized keys is a very public file. I'm almost positive it's not going to change it, but let's see. No, it did. It did. So there you go. So now you know how to do it the hard way or the easy way. Okay. Yes. So now you know the easy way and the hard way to do that. And you can log into your boost system, and everything else is fun from here out, right? So the last thing I want to show you before I end the boost today, and we didn't really take any breaks, so I'm just going to end. The last thing I want to show you is how you can get started doing the Vim tutorial. Now you remember that last week we did the Vim tutorial, and I don't like it, and I talked about why, but the Learn Vim tutorial that I'm making is not quite ready. It'll be ready next week. And when that is, I'll show you how to do that. So if you want to start practicing Vim and you want to do the Vim tutorial in your new system, just go for it right now. And this is what we were going to do this week. We were going to practice learning Vim RC and everything. The really great thing about this is that you have a completely uncustomized Vim on this machine. And that's good for a beginner because it doesn't have all the pretty stuff that my SKILSTAK version had. And that's good for beginners. They should know how to deal with that. So you're going to go ahead and start it. So what are you going to type? Vim tutor. Enter. And so now you have the ancient, broken, created by college freshmen tutorial that you can go through. And if you want a recap on this, I went over Vim for two and a half something hours last week. You can go get a very long-winded description of that, or you can wait for the new and improved Learn Vim tutorial that will be ready next week, that I've been working on. If you want to watch me working on it, I will be live streaming my creation of that tutorial as I did last night, and I'll be live streaming the creation of that today and tomorrow until it's done. So if you want to hang out and watch that while we're doing it and talk about what should be in the tutorial and what shouldn't, fine. If you just want to go and do the Vim tutorial right now, you have everything to do that. You have everything to do that, and you can practice moving around and exiting Vim and doing all this jazz, and just follow the instructions that are there. So that is all I have for the boost today. Let's go back and see where we are and what we plan to cover. Let's see if we cover everything here. What is the difference between the virtual machine containers? We covered that. Should I use a virtual machine or container for your workspace? We talked about that. I think you should use a virtual machine. We still are going to use containers. In fact, we're not going to do it right away, but you can install Podman. It's not installed on there, right? In fact, how hard would it be to do that? Let's try that. I wonder how hard that would be before we leave. Let's do one last thing. Sudo apt install podman and type your password. I think that's all you need to do, frankly. You remember all that stuff with Podman? And so now all that stuff is still doable, right? This is why we have a 20 gigabyte drive. All right, so watch. We have Podman now. Podman. Damn. All right, so now remember all this stuff from the quick start? Let's do that. Podman. In fact, let's do the quick start. Where is the quick start knowledge? Where is it? I'm just testing something here. So if you go to, where is it? Where is it? I'm sorry for the flashbang. I'm sorry. Get off of it, please. Okay. SKILSTAK and beginner boost, quick start. You see this? We're going to cut and paste that. We're going to cut and paste that. Copy to clipboard. I'm on my new VM, and I'm right-clicking to paste. And then enter. Enter. And now it's downloading the SKILSTAK image that we made for the overview. Same stuff. It's crazy because this is like, isn't this funny? This is the same thing the Podman desktop was doing. You know what the difference is? We are doing it from a virtual machine instead of the WSL's shitty virtual machine that Podman installed for us. Remember I talked about removing layers? So this is the best way to do this. SKILSTAK. It's misspelled on purpose. SKILSTAK. And I told you my container image was big. Remember it's 1.2? The thing that's crazy is that this Podman, this image is bigger than the virtual machine. It's actually bigger. It's actually bigger than a virtual machine. Yeah. But I want you to know that you still have it. You haven't lost anything, right? So the difference is that you have access to the virtual machine that's running Podman now, and you didn't have that before today. Before today, you didn't have that. I mean, technically, you could have done SSH into the WSL2 instance, but this is way better. But I'm just trying to show you that you still have all the same stuff from the boost, right? If you want it. So fishies and all that jazz. It's not quite done yet. It's thinking about it. I hope I don't fill up my hard drive. I don't know. It seems like it's... I don't know if it's going to work because we only gave it 2 cores. It's going to have a hard time. We only gave it 2 cores and 2 gigabytes of RAM, the host machine, the virtual machine. So it might not start. It might be too big to run. Yeah, because you remember how small we made this image, guys? Yeah. In fact, I think it's choking right now. I do. I think it's choking. Let's run top. Yeah, let's run. Again, see all the stuff that we're doing? We're like totally choking out Podman. God, look at this. Oh, we ran out of memory. Damn. That's okay, though, because we don't need it. We don't need it anymore. If you wanted it to work, go turn up the memory and it'll work. But you remember I said it was a machine and not a container? So here we go. Adding layer blob, make directory blob, no space left on device. I filled up the disk drive. I am so sorry. Look, literally say go package mode, let's say tools, blah, blah, blah. We filled the disk drive up. Yeah. So let's do again, another reason to use a virtual machine, because you get it's an actual machine, right? Let's do df, df-h. You get bonus commands here. Well, how come it filled up so much disk? I wonder if it's the host system. I wonder if it's the host. No, it's not. It can't be. Why would it do that? All right, let's try it again. Oh, why are you pulling it again? Oh, I must have run out of space for the disk to save. This is why people want containers to be small. 1.2 gigabytes is ridiculously large for a container. So this is why people like small, tiny. Okay, let's still do that. Let's do podman run at Alpine. watch how fast this one starts up. Actually, let's remove it after it's done. Alpine, here we go. This one will run, no problem. Boom. How fast was that? Because this is teeny itsy bitsy tiny little desk. That's why because it only takes like I think 2 megabytes for that version. Remember that whole thing about containers versus virtual machines? Containers are so small, entire containerized distributions are so small that they will run in relatively small virtual machines. And that pretty much describes Kubernetes in the cloud, period. So let's do this. Let's go run something else. What should we run now? Let's run, my other image is too big. Let's run Ubuntu. This is weird. Oh my God, everybody, your brains are going to melt. We're going to run Ubuntu in Ubuntu. What? That's right. We're running Ubuntu in Ubuntu. Yeah, but we'll try to do man now. Don't have any man, right? How about, you can still do all the other stuff though. Yeah, you can do apt update if you want. And you can use podman to practice upgrading. Yeah, apt, you can do unminimize. This takes forever. And you want to unminimize, you can't. This is a container, by the way. This looks like I'm installing a new operating system. I'm not, right? I'm installing all of this stuff into an Ubuntu container that's running in a container engine, running in Ubuntu on a virtual machine, which is running on Windows in VMware. In Ubuntuception. All right, so now we have documentation. Man ls. Oh, damn. Why didn't it do it? Still no man? Still no man? I'm only having to, I don't have to do sudo because I'm in root already. Apt install man. That makes me very sad. Yes, I want man installed, please. Is that if you bounce the container, updates are gone? Absolutely. Important to say that. Important to say that if I bounce the container, then all the updates go away. Absolutely. Thank you for bringing that up. So now what? Man ls. And just to, it's not very pretty though, right? Because it's an absolutely uncustomized container image. But as somebody suggested in the chat, what happens when I exit? Is it there anymore? Nope. It doesn't exist. Podman images. Here's all the images that we have. We have Alpine and Ubuntu. It didn't manage to download the other one. If you want to try Calican. The point is you can still use Podman. And Podman, using Podman to start images is a part of the beginner boost. As a user, it's still a part of it. And next year in 2024, we will go through the virtual machine installation step first. And then the thing after that we'll do is we'll add, after we do that, we'll go ahead and add Podman and show you how to run containers in addition to that. So how to run a container is still a part of that. The difference is this year is that I tried to teach you that before I taught you how to do virtual machines, and everything blew up with WSL. And so 2024, we will teach, just like we did last year, how to use VMware Player to install Ubuntu, which we did today. And then someplace along the line, we'll also learn containers. It probably won't even be the first thing. It'll probably be like near the end. And we'll talk about how to do it, probably to practice running web servers when we do web development, to make your own resume website. So that stuff's all coming up. That is really it. There is absolutely an Arch container. Yes, there is. Podman, run it rm Arch. I think it's Arch Linux dash rolling if I remember right. It's not Arch Linux. It's Arch Linux dash something. What is it? Does anybody remember? There's no tab completion for that. I don't know. You have to know the name of it. For this, you have to go look on Docker Hub to see what the official name is, and I don't know what that is. So, I want to say it's rolling release. I can find it. Wait, let's have exit on this one. Let's see. The name of Arch Linux distro. This is one of the downsides of not having a containerized version of the stuff I've been doing, is you won't be able to do searching. You're gonna have to install and configure that first, but that's okay. Is it Arch Linux latest? Is it? Okay, let's try that. Arch Linux. Pretty much doesn't resolve anything. I don't think there's a search command. I don't think there is. I don't know if there is. I don't know all of the possible commands. I'm just going to admit I don't know them all. I don't think there is a search. It's not like app search. You can't do like... It's another reason to use app, because you can search. There's a search command. Podman search Arch. Yeah, I don't know. How can you tell? I've never used it. Let's try it. So I'm learning something here. Users can limit number of results. Search limit 3. Filter is official. Registry Fedora project. Does it search? What I want to know is why it didn't find it. Arch Linux. Do we need to do what registry? I mean, you know what I'm saying? I've never done it. I don't know how to do this. Hits an API. Docker search is the thing. Yeah. People don't like Docker repo generally. Yeah, I know they don't. I've been trying to find a search for... In fact, where would there be another one? Arch Linux container, Arch repo container, images. Oh, whoops. Library Arch Linux is a canonical name in Docker. Really? The Docker repo. Oh yeah, we're not using Docker. I'm trying. Actually, I'm not going to leave this until I know how to do it without that. Arch Linux distro container. I don't want the Docker Hub one. I wanted something else. Best Arch Linux based user-friendly distributions. Official image. This is the Docker one. I don't want that. How can you get it besides that though? We could probably use Quay. I bet Quay has it. Maybe not though. It's just I don't know. I don't. You want to use Docker? Yeah. I mean, normally that would work because it would go to the Docker. Podman's not doing it because Podman's Red Hat, not Docker. I consider that an advantage actually. So, yeah. We'll still use a fully qualified name. Yeah, there we go. So if you want Arch, there it is. It's on docker.io. Yeah, it does. It works. So that's interesting. Okay, that's good to know. So Podman makes you put Docker in front. Obviously, Docker doesn't make you do that. So I find that interesting. So yeah, so you could actually do this instead. You could do run it rm and then just do that. There we got Docker. Yes. What you're getting, unless you look at the implementation details. You found the Quay one? Thank you, Zeddy. So if you want to use the Quay one, which is hosted by Red Hat, that is Quay.io. These are all different places to get container images. And it looks like you have to fully qualify it. Further, Arch Linux. And then now grab the latest by default. That looks like a bigger image, actually. That's a different image. It's a different image. Wait, no, okay, it's only got 2 blobs, okay. Yeah, so same thing. It's just, again, you're getting the same containerized images from different places. We're pulling them off the internet, and we're talking about different sources to get them. If you're a beginner and that sounds like, a foreign language, don't worry. The idea is that we're pulling, the cool thing about what we talked about with the difference in containers and virtual machines earlier, is that containers are so small, unless they're mine, that you can pull the whole container from any number of sources and you can combine them. So you can say, I want this container over here to run. And so people will put like a web server inside of a container, and then they'll put like a database in a container. And if they want to upgrade or something, they just intermix those containers. And that's pretty much the cloud native world in a nutshell, is a bunch of containers that are being managed together to provide technology and resources to people under the term microservices. That's what containers are. That's what Docker Compose, and Kubernetes, that's what they do, is they manage all of these containers doing different specialized things in different combinations, and all of that stuff is generally running on virtual machines like we're doing now, that are also running on hypervisors and hardware of different types. And a lot of times the actual machine is the hardware or the metal. These days it's going to be SUSE or Red Hat or something like that that's running the host operating system. And so the guest operating system very, very commonly is Ubuntu. And then the containers themselves are using whatever, but it's all Linux, right? So it's all Linux except for at the very, very lowest level. And that's why you should learn it. This has been fun, but I think we're done now. We did our review one last time. I've been saying that. Oh, how am I doing on time? I didn't even look. I didn't take a break. I just kept going right on through. I had a big old breakfast though, so I made sure to. I drank a lot of water too. So what are we doing now? Is a good question, right? So let's just do week 9. So we've covered it all. How to get a virtual machine, which is a virtual machine software. I've said VMware Player is free. It's great for beginners, and you can grow. You can buy a virtual machine workstation or player if you want to. I don't recommend you do right now. I think you should know what you want to do first, and maybe that you want to make your own virtual machine server later, and you can do that. On a separate host. Save up your money. I don't know. Don't go to 1 semester of college. Use that money and spend it on a server so you can build your own home lab. You'll learn way more. You'll make more money by having a home lab than you ever will for that 1 semester of college that you used to pay for that server. Which Linux distribution is best for beginners? We've talked about that. I personally think the Ubuntu server is the best Linux distro for beginners because you can SSH into it and practice using it as if it were any other server out there on the internet. I realize that's at odds with most people who recommend, whatever desktop distribution of Linux. As we've already seen, it's much harder to install those and to set them up, and then we have to fight about desktop intros, and it doesn't run on Windows unless you have a virtual machine. By the way, if you have the resources for this, I'm going to give you some bonus, okay? If you have the resources for this, let me give you a bonus task, okay? Particularly since we're in science and tech and there's some hackers out there. If you want to go the extra mile here, you can go do a search for Kali Linux, and you can install Kali Linux, graphical Linux that will run in a virtual machine. And I want you to do it as a bonus because when you do this, you will notice right away how slow a virtual machine is running as a desktop. Unless you have a kick-ass gaming server, you're not going to want to do this. But if you want to do this just to see the difference between running a headless server, which is what we're running now, and running your own desktop. Hell, if you want even bonus stuff, go download Windows 10 or Windows 11 and install that into a virtual machine. You now know with VMware Player, you can install any operating system that will run on your hardware. Okay, and you can practice doing that. And being able to install and run a virtual machine is a core skill for any technologist, focused PhD machine learning person, all the way up to like senior hacker dude or person. So you can go down here, install our images or virtual machines, limited direct access to hardware or hardware systems. When you run the installer images, you have to actually run through them. So you can click on the installer. You can download that, and I will leave you with this. I'm not actually going to do it. You can go get the latest Kali Linux, and you can boot that up, right? Now, I don't think you're going to be able to have two running at the same time because of VMware Player. You probably wouldn't want to do that anyway. And by the way, if you do this extra credit, don't skimp on RAM, okay? Make sure, you got to remember, when you're running Kali Linux desktop with a graphical desktop, you're going to need to give every available free resource, it's like you're playing a video game, to that thing. That means you should give it pretty much almost all the RAM you have on your computer, except for maybe the bare minimum to keep your host operating system working. And you should not skimp on disk at all, because you're going to want to install a lot of software over there. And you're also not going to want to skimp on CPUs. You probably want to give it as many CPUs as possible, leaving maybe leaving two around for your host machine, but give all the rest of the CPUs to it. And then when you're running Kali Linux, it's going to basically take over your computer and all your resources. And if you do that, you'll get some snappy response. If you don't do that, you'll end up having it crawl. I mean, it'll take forever to scroll the mouse across the screen and a bunch of other crap. And many of you have computers that won't do this at all. In fact, when I worked at SKILSTAK, our Acers, our cheap, $300 Acers we got from Target, barely even booted a visual Kali Linux running in this way. VMware Player will be one of the fastest, especially if you have GPU pass-through, but it's still going to be slow. But the reason this is bonus is because, again, we're just SSHing into the terminal. That's the fastest way to do this. You'll get nice, snappy response. But if you want to actually see what a desktop environment looks like before you buy it and put it on your bare metal, you can go test out a whole bunch of them. You can look at the different ones. You can go try PopOS. You can install PopOS. So here we go, PopOS. You can go find PopOS if you want to do that. I did, but I don't want to do it anymore. If you want to install PopOS, you can install that and run PopOS on top of that. If you want to go try Fedora or Rocky or Arch or Parrot or, anything, you can take any operating system, any operating system installer image, the ISO image, any image, and you can use that image to install it into a virtual machine and run them one at a time to see about them, see how you like them and stuff. Now, if you do that, just be aware that you might have that problem with the known host issue if you're SSHing into it, right? But you probably won't have that problem, because if you're testing out desktop Linux systems, then rather than saying, I don't want to use this ugly terminal, instead of seeing a black and white console in a headless Linux like we were using with Ubuntu Server, you'll see this beautiful, dragon on the back of Kali Linux, and you'll be able to use Burp Suite and all those, stupid, ugly graphic applications that hackers have to use, which doesn't make any sense to me. But you can use them. You can go in there and do that. You can even play games. You can play Linux games and see how far you can go with that. But that stuff is not required for the boost, right? But that is definitely something that we would cover as you transition to Full Metal Linux. So this is yet another reason to make sure that you learn how to use a virtual machine on the beginner boost, because that is a stepping stone to preparing for Full Metal Linux, so that you can test out those Linux distributions in advance in a virtual machine and make a solid decision about which one you want to use. Now, in the Full Metal Linux boost, it's not a boost, I don't know what to call it. I'm going to do Linux Mint because that's reliable. I know it works really well. But you can install Kali. Anybody. It doesn't matter. Install whatever you want, and and then practice that. We're actually also going to play with Raspberry Pis and stuff. That is it for me today. You install Zoan OS on your laptop. Is that a bad idea? I don't know. It's not going to get you a job, but it probably is cool. Yeah, you can install Debian 12. You can install a bunch of stuff. I'm going to read through the chat really quickly before we wrap up today. I'm going to put bonus install another operating system using VMWare Player. Is it VMware like this? You could say PopOS, Kali, Arch, etc. All right. I'll put that there. Just playing around desktop. Yeah. And if you want to try Nix, we could try that too. Arch, Nix. Seriously, I'm not against those other operating systems. I just don't think you should waste time on them until you learn Ubuntu and first. And then you can learn the other ones. Because then you're employable, right? You're not employable until you know Ubuntu and Red Hat, frankly. You're just not. I'm not the one who makes those rules. That's just the way it is. All right, a little bit of read through in the comments here, and then we'll be done, YouTube. Yeah, Bash is the same everywhere. True. KDE, Plasma. Yep. Why do you hate Ubuntu? Debian is not greater than Ubuntu. We're not going to fight about that. Show me one production enterprise that uses Debian. One. Just one. Show me any jobs that are hiring people that know Debian only. Zero. Is Ubuntu based on Debian? Yes, it is. People who get like all up in arms about free software and stuff like that don't live in the world where you have to have a job. And most of them aren't employed, actually, or they're really passionate and their actual job is like administering Windows NT systems from 1994. It's true. They live in this, and I was there. I used to live there. I used to live in this, oh, I'm not going to do anything unless it's completely free and proprietary software. And then I had to have a job. I would rather have a job working with proprietary infected, we'll say, Linux, than having a job not doing that. Not using Linux at all. So Red Hat, Oracle Linux, CentOS Enterprise, I won't. The distro doesn't matter. You need transferable skills and you should be distro agnostic. Yeah, and the person that's saying that also said, I will never do that. Fuck jobs. I don't need one. I am free. Well, that's not most people. Most people want a job, and the people that are watching this want a job doing something with the terminal and Linux. So, I mean, you can judge me all you want for telling people to learn things that will get them actual jobs that pay well. Hey, look, you can still think that inside and just prostitute yourself to use Red Hat, oh my God, in order to get a job. But you can use Arch on your own computer. And Full Metal Linux is kind of that thing, right? Full Metal Linux is going to be about the hobbyist things. It's going to include, you know, Arch and running on devices and Raspberry Pis and things like that. Stuff that you probably wouldn't get a job doing, but will make you a better Linux person. They will make you a better Linux person by far, but they won't necessarily get you, you know, that position that requires that you know how to administer Red Hat or something like that. So I love NetPlan, actually. I think it's awesome. I think it's one of the best things that was ever invented. Yeah, the people, okay, I think the boost is over. The people that are arguing are not beginners. No, there's a bunch of non-beginners that have all kinds of opinions. What else is new? If you're a beginner, just get ready to deal with the opinions. And as you form your own opinions, there's nothing wrong with strong opinions weekly held. That means that if you're presented with new information, maybe once a week, that you change your opinion, right? And you've seen me, I changed my opinion. I thought desktop podman was going to be the way to go for the beginner boost. And I changed my opinion on that real fast when WSL2 blew up. So now the preferred way is back to what I was last year using VMware. I do hope this stuff is useful to you. I really do. I know this has been a long video. I see Het Tanis is in the room, as well as other really awesome people. and they're having fun with me as usual. The beginners are being quiet because the chin beards and veterans are taking over the chat as usual. Oh well. If you're a beginner and you're lurking and you're watching this, I'm talking to you. Thank you for being here. Thank you for putting in the time. Thank you for daring to learn Linux and forgiving me for making mistakes like telling you to use Podman Desktop. You learned something, like along with the rest of us. And we will see you next time. Next time, by the way, we will be back on track. We will be learning how to configure our Vim line by line, and we'll be going through the VMRC. As I said, the Learn Vim tutorial will be done. The app, you'll be able to run it on your machine, and it will be way better, and it will be covering the same stuff I covered last week. And I'm also planning to make Learn VimRC, which will do the same thing with your RC files. So it'll take you through all the preferred settings in the VimRC file as I see it. So that'll help you tutorial you through the VimRC file if you want to do that. And I'm going to be creating Learn Bash, and I'm going to be creating Learn Tmux, and I'm going to be creating a Learn Links. Those are going to all be executable tutorial binaries that you'll be able to run from your computer, your new virtual machine you just made, that will guide you through how to set up that stuff to make your own and make your own decisions. So then you can customize without having to use the one that I gave you. And that's what it's all about, right? It's all about choice, and feel free to make your own choices. But I suggest that you at least stick with a method, like martial arts, right? In the martial arts, it's not like you switch schools of martial arts every week because you can. You kind of try to find one that you want to dedicate yourself to for a while, and then you dedicate yourself to that, and you study under that master, whoever it is. Go watch Karate Kid, and you do wax on and wax off, and you might not understand why you're doing wax on, wax off, and you might get mad at your master, but you at least go through it, and then you kick ass and take names at the competition at the end, right? And at that point, if you want to change schools or go do another martial art, fine. But the idea of guru mentored learning is that you try as best your ability to find somebody to trust to take you through it all the way to the end. And then you learn at least their method, and then you can decide that you want to adapt to that method, or you want to throw their method out or something. And unfortunately, that's the only true way to do this. You have to kind of act on faith to find a good person to follow. And all of us mentors on YouTube and Twitch and every place else, we have a different school, and we have very different priorities and different ways of kicking ass. Can they kick ass like me? Probably in a different way. Do they have vulnerabilities that I would take advantage of? Would I sweep the leg? Hell yeah. Maybe they wouldn't. Maybe they wouldn't know about sweeping the leg, but I can sweep the leg. So, that's kind of a part of this whole mentoring thing. And I only have to say that because anybody that's in my Twitch chat right now has just gotten overwhelmed by veterans who've taken the chat over. And I promise you, beginners, you're going to make it. You're going to be fine, and you're going to be able to have arguments and act smart and flex to your heart's content and all of that jazz later. For right now, just learn it. Just stay with the basics. Stay positive. Stay confident. Stay dedicated, and stay patient. And patient with me for making mistakes. Patient with me for talking so much. For those of you who like a faster person, you can put me on fast. I've chosen to overly explain everything rather than to under-explain everything. And I know that that's driving some people absolutely crazy. It would drive me crazy, but I've found that works for the best for the most people. That's all I have to say for now. Thank you for being here, YouTube. We'll see you next week.